Hello everyone, my name is Nathan, otherwise known as Old Man Builds. Gerald's going to be here in just a few minutes. We're going live. We are trying to build circuits today, or we're going to build one for a Tesla coil, that's for sure. We're going to look at exactly how to build it. We're going to go over point by point. So what do I mean by that? Every solder point that I do, we're going to go over. No more theory, we're just going to build this right. Anyway, guys, I hope you enjoy it. I'm going to put the video up right now, and hopefully Gerald will come in. When he does, we'll stop it and we'll take a look. Hello, my name is Nathan, otherwise known as the Old Man, and today we're going to build ourselves a better Slayer Exciter circuit, one that's going to last you for hours. Anyway, enough talk. Let's get into the build, and I'll show you exactly how to get it done. All right, we're going to build out this Tesla coil right here. We have our power source. It is 50 volts and 10 amps. We're probably only going to use 40 volts on this. It's most consistent that way, and probably anywhere from 3 to 6 amps. So let's take a look at the things we'll be needing today. Here's a power supply. It is 12 volts, 1.5 amps, and that's just going to power our little fan here. That's going to go to our heat sink. We have a heat sink. We have our MOSFET here. The MOSFET is a 2SA1962. Don't worry about it. I'll put it on the schematic so you guys have it. We have a 47K ohm resistor. We're going to need one of those. We're going to need a little heat shrink here. Again, it's 1/8 to 1/16 heat shrinks, pretty small. We're just going to use a couple twist ties here. And that's pretty much it. We're going to need a soldering iron and a little bit of solder as well here. And we're good to go. Let's get into this, guys. Let's go ahead and start putting this circuit together. I'll get it a little closer. So, I have a schematic right here. It's a pretty simple point-to-point schematic, and we're just going to follow it. We're going to start over here, and we're going to work our way through. Don't worry about this. I'll put the schematic later in the video and walk it through one more time. But let's just go ahead and solder it point to point and show you where it goes. Now, first thing we're going to do is connect the bottom of our Tesla coil. Now, that's this wire here. And what do I mean by bottom of my Tesla coil? Well, right here we have our number 2 coil, and that will go to this wire right here. So the bottom of that goes to this. So that's the only wire that gets hooked up from the number 2 coil, and the other one gets connected to nothing. It goes into the air, and that's where your spark's going to go. Now you could put a toroidal on your Tesla coil. That's up to you. That's the top piece that goes on there. I don't necessarily think I need to do that today because we're going to build it for resonance, not for sparks. We're just going to solder that right there. And you notice I put it in there and I left a little bit out on the end. That's because I'm going to add the resistor onto this side. Now this is opposite of what you're normally doing. Normally you're putting the resistor on the other side. Again, we're building for resonance here, not for sparks. So I put it on this side. Now, your resistor is bipolar, so it doesn't matter which way it goes. All we need to know is that we put it in here. Put a little solder on there. Make sure it flows right in there. And we are good to go. Let's take a look at it. We just have a little resistor coming off of there. And you're going to have 2 wires that come into this one. This right here is going to be the negative wire to my power source. And this other white wire that I have right here will go right into the bottom of our Tesla coil. So when I say bottom on this one, I'm talking about this coil here. This is our number 1 coil. Top, bottom. So this is our bottom wire. So let's go ahead and do those. And both of those get hooked to the other side of this resistor here. So let's put a little solder on. Again, solder anything onto these wires that you need to. A little more. Make sure it flows on there. Okay, we have a good connection. Let's move on to our second one. Again, we'll put a little more solder on here. And we'll just connect that. Take out that little piece right there. So far, we have 3 connections. I left them long like this so that you can see them go in there. This one, before the resistor. The power wire to our negative right here after. This right here goes in to the bottom of our number 1 coil. That's pretty simple. Let's go ahead and hook in the top. This is the top to our number 1 coil right here. Now I soldered these ahead of time on the ends of these just to prep them. So all I'm going to do is run some solder here. This one's going to go right here to the center. Let's make sure the connection's good. And we're good there. Now, the very last wire we need to connect in is the positive. This is my positive going to my power source. Make sure it's in there. And this is pretty much what you're going to end up with in the end. This is the whole circuit, guys. Positive right here, this red wire. That goes to our power source. This wire right here in the center goes to the top of our number 1 coil. This wire here goes to the bottom of our number 2 coil. 47K ohm resistor. This wire right here goes to our Tesla coil, and it goes right on the bottom one. This white wire right here goes over to our negative on our power source. That's pretty much the circuit, guys. Guys, want to say hi to Gerald? Gerald, what's up? Gerald, I couldn't hear your mic. Are you on? Nope.
Sorry.
Right on, brother. Yeah. That was a pretty quick and easy, simple circuit. I'm going to show you guys in just a few minutes the actual MOSFET, transistor in it. I always want to call it a MOSFET. Sorry. Habit.
I hear you. I do the same thing sometimes. Or I'll call it, I like to use a horizontal deflection transistor, and I'll call it like a MOSFET or a FET. I get complaints about it all the time from friends.
People are pretty specific about that, yes.
Because you know what? When it comes to engineering this stuff, if you're not specific, then people are like confused or they think you're lying or whatever, right? So yeah.
Absolutely.
Yeah, got to be specific. What was the transistor that you used?
I'm going to pull it up right here for you.
Awesome. Nice.
There we go. 2SA1962. If I'm not mistaken, it's a PNP. Yeah, right at the top right there. It says PNP. And it is 230 volts and 15 amps. Now, I will tell you, heat matters. So if you bring too many amps in this and push them back into it, you're going to blow it. So about 40 volts is what I run this thing at. It run all day. You can literally go turn it on, go walk in your house, sit there all day, watch TV, and come back out. It'll still be on and won't blow up at all. It's one of the best Tesla coil things ever.
That is an awesome circuit. I was just playing with one of my circuits. I haven't I have to admit, I wasn't quite ready for this show. This is the first show us getting into to showing people. Yeah, so I didn't do the like. I would love to record me building the circuit so everybody can see me building it and seeing how it works. I think I'll have to wait till next time because I didn't get that done. Sorry, everybody.
It's all right. Now, I got to answer a question. So, yes, it is the circuit negative. And the coil itself is wound in negative. Normally, you do it to the right. I did this one to the left. So, little bit of negative everything. Normally, when you do a NPN, the actual wiring is going to be different. So if you don't buy this exact MOSFET, you can always hit me up. I have another circuit for a NPN, and it's just as simple. It's just difference in where you put the actual 40K ohm resistor and where you put the hot and cold. That's it. That's about the simple of it.
Yeah.
But I do want to show you the thing running, Gerald. So
yes, please do. I'm going to just adjust my camera. Give me 1 second.
All we got to do is wire in this little fan, and we should be good to go. Okay, we're going to set up this fan now with this power pack. Take a look right here. 12 volts, 1.5 amps. We don't need any more than that. Here's our PC fan here. Real simple.
Nice.
Now, let's look at the end that matters for us. 4 wires. Not really going to be a problem. We're going to connect it with 2. Let's see if I can't get it to show. Right there. Okay, on the very top, it has the line. Then it has TKG and a number. Now, we don't need the TKG or the number on this. Those two are irrelevant to us. The line on the very top, that's negative. The one right under it is positive. There's the only 2 we need out of this. So let's separate. That goes for any fan, by the way.
Any fan? Like any small DC fan?
Yeah.
Nice.
The other one are basically a data cable, and it's PWM, so it's going to have a PWM negative. Signal. So when you look at it, keep reference. The outside wire here, that's our negative. Yeah.
I only use the red and black, so I never understood what those other 2 were because I always use just the red and the black.
Yeah. Well, now you know.
That's awesome.
Everywhere the line is the negative. The two other one's a data cable, and the other one is a PWM one. Okay, so if you want to use those in something else, go for it. But the only 2 you need is a positive and negative, and those are it.
That's awesome. Now I know.
Yeah, well, it makes it really easy to put it together.
Yeah, that's awesome. And that's the only fan on your stuff.
Pretty easy. Let's strip these back real quick. Thin wires, just make sure you don't take off too much for us to start fraying wires out. All right, that's pretty simple. Let's look at our power pack now. All we did was cut off the end of this thing. So we're going to strip this one back. Here's what you get. You got outside shielding here. We're just going to go ahead and peel that shielding back. You should get all of it. There's a bunch of little wires. Pull them together. And we're just going to twist tie them. Or, you know what I mean. Pretty simple. Now, this white wire is always positive. These ones right here are always negative. And there we go. Now, we're going to get some heat shrink out here. Take a piece out. Now we'll bore everybody through the heat shrink part. I'll go ahead and move it forward just a little bit. Yeah. That stuff just takes time.
Yeah. Yeah, building circuits sometimes are a pain, I tell you. Sometimes it's simple, sometimes they're finicky.
Yeah. All you got to know about the fan is which direction it goes. Anytime that you see the this side right here, that side,
Yep,
that's the side that always goes towards anything you want to cool down. The other
that's
side,
exhaust.
yeah, that's the side that pushes the air towards you,
Yeah,
and the other side is the one that sucks it in. So as
that
long
makes
as everybody remembers that, you're golden. I just got a zip tie it to the back because I was being cheap.
you should see half my stuff is cheap. So I like this comment here. Right, fancy with the heat shrink. I use it myself, but sometimes it's a pain.
Yeah. We have minimal breakout at the top. In my case, that's good. I just want to see that it's lighting things up, as you can see. Okay, just real quick before we go on, I just want to tell everybody, this is a DC circuit. It's forced oscillation is what a Slayer exciter is. Means it's going to force it to oscillate. You're not going to need to oscillate it as much as you would a regular Tesla coil. With a spark gap or a ZVS or anything else, not real particular. As long as you don't go too hot, you won't blow it up. Okay? That's the only main rule here. And because it's DC, you're not going to get a lot of breakout on it. You are, however, going to get a lot of radiant energy. You can see the lights behind it's already lighting up.
Yep.
And I barely got a spark on this thing.
I gotta say, Nathan, I'm astounded. You're the only one out of maybe 1,000 Tesla coil videos that I've seen. You're the only one that puts a wire down the center. Just saying.
It's an advantage, let me tell you that. Once
Yeah.
everybody learns it, then they'll all do it.
It's an advance by far that
Oh, yeah.
everybody ignores. They think they want to make sparks, and sparks are cool. They're awesome. I love them. I blow stuff up all the time. But that's not the intention, I think.
Yeah.
You know what I mean? Or it should be. It should be using that power. No sparks. Let's put it somewhere else.
Let me just tell you this so you know. Once you put the wire down the Tesla coil, it does not matter what shape the next part is. Doesn't matter. You can hook it to anything, okay? As long as it's metal, you can hook it to an anvil, whatever. As long as you can get it to resonate when it's hooked to it, you're golden.
And I always wondered about that because there's pictures of when Tesla was doing his Colorado tests where a few of his Tesla coils actually had like a center post in the middle of them. Yeah. And I always asked about that. Everyone I could get that would answer, and nobody understood what it was for. And I think what you're doing is exactly what he did at that.
It's a robber. It steals the energy, and it turns it cold. You got to understand the Tesla coil is a vortex, and if you do that, you see it like this every time.
Yep.
If vortex is in the center, that means when you put the wire down, if you got an active Tesla coil, it's really cool, like a good one. You're going to see all the electricity attack it. Okay, from every angle, it's going to be a beautiful light show. But what it's doing is it's pulling the energy out of it. It's stealing it. Okay, it's not stopping the oscillation. The oscillation is still going to go off. You're still going to be able to light up light bulbs, but it's going to steal energy right out of it.
Interesting. See,
one of the coolest things.
Yeah, you know way more about Tesla coils than I do. I've never claimed to know much about them, but there's certain things that I never understood. And that wire down the center, man, you blew my mind with that. So that's awesome.
Yeah. You know what? We're just getting started because this circuit's awesome. So let me get into the good part for you.
I'll shut up.
Right behind it, we're all lit up. So let's go ahead and let's take it to the dark and let's see it. And then I'll push this thing the rest of the way. I believe I only have, 50 volts in this thing, maybe 60. So there we go. We'll set the camera right there. So let's take a look real quick. Got my tape measure. There we go. We use some light. And right about 8 inches right there. Breaks down. So what we're getting here is we're getting 8 inches that it's really bright. And then at about 20 inches is when it breaks down. And as you can see the lights behind it, we're still glowing. See right there, we pick it up.
Nice.
So right now for our gravity flyer, this is actually really good. We have a consistent voltage on here. We have a consistent distance. We're actually making good progress here. This circuit's going to last probably what? It's already 45 minutes or so, 30, 45 minutes, man. We are going to last for hours on this circuit. As you see, it's just a MOSFET hooked up. I don't have any diode protection on it.
Sorry, it's a transistor.
I have one resistor on it. Again, it will show a schematic here. Let's go ahead and light this up. Now, the one bad thing is it does heat up when you get over 40 volts. So let's go ahead and take a look and see what more we can get out of it.
By the way, only me put the tape measure over there by your Tesla coil while it's still hot.
So you can see our breakdown increase.
Try it and find out, right?
Now look at that.
Our distance doubles.
Wow.
It goes right off the camera, it's still lit.
Over here.
And that's that circuit.
Red hot.
Yeah, as soon as. So let's see if we can't get a picture of this. So you see how bright it is right there, right?
Yep. And the other bulbs on the table got brighter when you did that too. Go ahead.
Yeah. So it pushes it right out. Now, I'll just be honest with everybody. My Tesla coil is not oscillating properly. Okay. I do not have enough winds on my number one coil to make it oscillate properly. When you have it in resonance and you attach this thing, I guarantee you maybe another foot, maybe 2 feet of distance on this coil without heating up. Now you see it heating up here. Okay. I went over 40 volts. I'll max that power supply when it's oscillating properly.
Oh, yeah.
Oh, I just thought it was so cool that I could build something that wasn't 100% correct. It forced the oscillation. It worked perfectly all day at 40 volts. I mean, how much more can you ask of something? Well, maybe another 10 feet.
Yeah.
With
But
some
hey,
other coil.
you know what? All day like that? That's awesome.
Yeah. And it doesn't trip out when your gravity flyer, like I have my gravity flyer attached down the center.
Yeah.
At 40 volts. Doesn't even affect it. As a matter of fact, it resonates better. Because my Tesla coil is out of resonance, right?
Yeah.
It's at about 900 kilohertz is what this coil is resonating at the number 2 coil, right? My number 1 wind is so far out of that. But because it's a transistor, it's forcing the oscillation. It doesn't have a choice. Okay, it's going to do it for me or blow up. Those are the only 2 choices it has. That's it. So
is the gravel flyer expanding its capacitance?
Yes. It actually will expand it by about 310 kilohertz because of the weight of it and size. So what that means is at 900 kilohertz, I'm bringing the frequency down to about 600 kilohertz, right? So now I'm putting it in a better resonant value with my number 1 coil. So it runs even better when I put the wire down the throat and take energy from it.
Becomes part of the whole system.
That's right.
That's awesome. That's the way you want to do it. That's the way you want to do it. I love that. I noticed before when it was close and you had the tape measurement, when you got that small fluorescent closer to the coil, your bigger coils got brighter every time. Yeah, that's pretty interesting. I'm not sure if I've seen that before.
It's
Unless I just didn't pay attention, but I
Well-
don't think I've seen that before.
this
Go
is
ahead.
normally when people tell you about their Tesla coil, they're always telling you about AC, right?
Yeah.
Because it always shows a sine wave. Yet when you put it in a Slayer exciter, they accept the fact that it's a DC. But then they try to take on their oscilloscope and kind of curve the top a little bit on the square wave and try to make it look like an AC. It's not. Guys, what comes out of your Tesla coil is potential. It's a sine wave. It's not AC, it's not DC, it's potential. It always has been, always will be. However, when you connect your DC circuit, it's radiant energy. When you connect your AC circuit, it sparks out the roof. They're built different, so they react different.
Yep. I agree with that totally. I never, you know what? When it comes to making sparks with the Tesla coil, I don't think that was Tesla's intention. I think that was part of the way that he put out his patents, because he hid a whole bunch of stuff. If you put about 5 or 6 different patents together and inverse the Tesla coil and make it an antenna, you can do a lot with what Tesla created. I think he had it, but he pulled it apart, released it in different patents. And like I said, when it comes to the Tesla coil patent, you invert the whole circuit and it acts as if it's a radio antenna. So if you can send the energy like you're sending it, I wonder if you had the identical Tesla coil 10 feet away, would it pick up the same energy that you're using to project it?
Okay.
You know what I mean? Creating the loop.
So if I built the Tesla coil with the same number 2, right? With the number 2 coil, exactly the same frequency, everything. I could put it 2 feet away and it would pick up the energy of the first Tesla coil that started, and you'd be able to pull power directly off of it because it's looking for resonance values. So if your resonance value of your original Tesla coil matches the resonance value of your second Tesla coil, they'll resonate together.
Haha.
Resonance is one of those things that's like 2 ships in the night. If they resonate together, they'll find each other. If not, they'll pass by without even knowing each other's there.
That's true. Yeah.
So anything that has the same resonance value, you start to pick up. So if I wanted to build 1 Tesla coil in the center and 4 on the outside, equal spacings apart in a square, then every single one of them would take in the energy, and I could dump that energy into batteries without a problem.
Oh, wow. You just made me think of, what's the name of that gentleman's system? I'm sorry, it'll come to me after, but he had like 4 Tesla type coils, and he would put them in resonance with a neon sine transformer. And he'd collect the energy with high voltage capacitors on the back end, and he'd use that power, and it didn't affect his primary circuit. So I think what you're talking about is kind of a lot of like that. That's just, you're blowing my mind, Nathan. That's great.
Yeah.
Have you ever tried 2 Tesla coils in the same room, trying that experiment?
That is one of the things that I actually am going to try to do. I have right now a gold one right behind me. And what I want to do is build a second one. And I'm just going to do transfer of power. That's it.
That makes sense. Got somebody walking by here. Give me 1 sec here.
Okay. Yeah. Well, to be honest with you, man, I removed them. It was a YouTube thing. I'm monetized on my channel, and they won't allow me to have them on there, so I had to move them. So I'm sorry for that. For everybody who checked in for those things and those videos, I'm no longer allowed to put them up. So that's what's going on there.
Yeah.
So, yeah, resonance right here. So we're going to have to get Mike over there with the Tesla coil. We're going to have him build one so he could check it out. So I think he'll be impressed once he finds out he can put them into multiple coils. I think it's going to blow his mind. So
Well, Mike does, right?
Yep, Mike right here.
Yeah, he does. He gets it done. So Mike, you're awesome. Just saying.
Hello, goodbye. I'd like to put it up, but I can't. I think that's funny.
What's that?
Oh, it's in the comments.
Antenna cam. Yeah. Yeah. Oh, even Mike Faraday's here, or Faraday Energy Research and Development. Mike is here. The other Mike.
Oh, here we go, right here. Mike, big shout out. How you doing, guys? What's up, man? Oh, man.
Yeah.
There you go. Bernie's here.
Yeah. Sean Calderon.
John's here.
Yeah.
John's a master of Tesla coil, so I'm barely a student compared to him, okay?
Well, I'm a student to all of you, so there you go. I tried building a Tesla coil and failed at it miserably, but geometry seems to be my thing, so I get into it like that.
Yeah, there's nobody like geometry like you. So I'm going to put up real quick, just so we can take a look at it one more time, just the simplistics of it.
Yes.
So here's the actual circuit. I'll hit mute. We can talk while it's playing.
Okay.
There's not a whole lot of connections to this thing.
Yeah, I got a simple circuit that I can draw on the whiteboard, but I'd much rather solder it and do it kind of maybe even live next time.
Yeah.
I'll set up my secondary camera and we'll do it live. I just wasn't set up for it this time. My workbench is still a little messy.
Hey, I don't blame you, man. I got a bunch of stuff on my workbench too.
Working on 3 projects at a time, man. That's just how it goes, right?
Yeah.
I love the simplicity of this circuit, though.
Yeah, it just makes it nice because you go, okay, I got a transistor.
Yeah.
I have, there's not even a diode in this thing. It's just a resistor right there, just a 37K ohm resistor, 47K ohm.
Yeah.
And a bunch of wire. That's it. So just so you know, when I built this coil originally, I had no idea how a Tesla coil worked. I got some wire. I literally spun this thing out, right? I didn't even have a setup to do it. I took my soldering iron, I put the wire right there, and I put my soldering iron through it when it was cold, right?
Yeah.
And then I took my thing and I just wound it like this until I got this thing wound. How it came out looking that nice is beyond me.
That's great, man.
It was like some redneck engineering stuff going on there. I'll tell you that right now.
I got to pull one of my old coils out of the box there. If you looked at it, you'd laugh your freaking arse off, man. I tried to go for an open core coil, and it looks like somebody puked out a bunch of copper into a mass. So I understand, right? Like when we jumped into this stuff, I could just imagine some of the projects out there for some of the experimenters, right? We should do a show on just our failures or our mess ups, man. I got a whole box of them.
Oh yeah. Oh dude, I got buckets behind me and they're filled with broken parts. They're either busted because I blew one part of them up and didn't go back and fix it yet. And those are keepers, so I can go back and do it again.
Yeah.
And then I have old TV circuits in there from CRT TVs.
Oh yeah.
I love the MOSFETs in them. Those are awesome. They don't die a whole lot, so they're great. And massive voltage, like 1600 volts and like 30 amps is what they go to.
Yeah.
So I wanted to hook one up to this next. You know what I mean? And see what it would do.
They fire really, really fast, and my coil likes that, right?
Yeah.
So I imagine a Tesla coil is going to love it. It's just going to scream.
Yeah.
Because it's a very high fast rise time and really quick fall time. So it's like bang, bang, really fast, right? Love that.
Oh, yeah.
Yeah. Yeah, that's what those circuits are good for. Unfortunately, those horizontal deflection transistors, the 1600 volt ones, I blow them like crazy. I have to be careful when I'm I have to have a load on my system or the transistor blows. But if I have a load, I can dump tons in there. My load will define how much maximum input I can put on the primary. It's strange, but that's how it works.
Do you put any fan or anything on it?
No, I bet you that might help. Yeah, that's kind of a dumb move on my part. Never even thought of that. It's the heat that's killing it, right? So
this right here, check this out. Let me
I got a few. Oh, that's a nice one. That's a turbo fan.
So this is from AMD. It's their heat sink for their CPU.
Yeah.
You can see I just drilled a hole in it. Okay, and then I hook the transistor to it there.
Yeah.
And you can use thermal paste. You can also use the little pad things. This right here is just one of those little pads that go on there.
Yeah, I use those.
So anyway, you could use either one of them, but one of these things was $6 on Amazon. And let me tell you, it's perfect for it. All you have to do is wire in the fan, just like I showed you earlier. You're good to go. I absolutely love these things. And they got little bolts on them so you can hook them to stuff when you 3D print something.
Yeah, we talked about a 3D printer. I got to get on that. I think I'm going to get on that today. I was looking around earlier. I didn't find what I was looking for. So I'll keep looking. I need to find one. With a 3D printer, things are going to go a little quicker.
Oh, well, yeah.
Yeah.
That's for sure.
Well, I've been old school since day one. Take the TV apart, pull the circuits out, pull everything out I need, build it right there, you know, and if I needed a case or a box, I'll pull something apart that's garbage, gut it, and I'll use that. Yeah. So, yeah, but a 3D printer makes it much nicer.
Well, I can tell you right now from having a bunch of them sitting around here, you can actually see one in the background by all my Tesla coil right over there.
Mm-hmm.
I actually pulled the whole thing apart and built a bottom piece for it. So,
oh, really?
Oh yeah, dude, I tear these things down to nothing and rebuild them. Give me a second. I'll walk over and grab it and show it to you.
Sure.
Let me remove myself real.
Definitely be worth it. I want to get into 3D printing. I remember seeing your wall. You had like 6 of them along the wall, and I could tell when you start printing, you go to town. You get her done. So the fact that you know how to rip them apart and rebuild them, and that's awesome because I'm going to pick your brain more than once I get mine. And I have the one that you were telling me I should get, so I'm going to work on that. You're right, Mike. They're not exactly cheap, but well worth the cost once you put in the amount of time that it will cancel in comparison to building it from scratch, right? So that's awesome. I look forward to getting into printing. I know there's a bunch of others like Jeremiah and, I'm sorry if I forget his name. I think it was Thomas. Was talking about 3D printing, and yeah, that's the next step for me.
So this right here is my CR10 mod that I did. Just a basic CR10, but you can see I put this whole thing underneath it. Okay.
Yeah.
So usually there's a box that comes on the side of this thing. So I removed that. I built this one up front. Okay, it's all touch panel. The other one you have to scroll through.
Yeah.
Use the PEI sheet right here when I put them on there.
Yeah.
This thing is absolutely beautiful. So instead of getting something you have to put glue sticks and stuff on, this thing, you put it on there, it just snaps off a print, no problem.
Oh, that was the thing you mentioned, because it does that bubbly popping thing.
Yeah. So
there's a scientific term for you, Nathan. Bubbly poppy thing. All right.
You could see right here, I put a Batman logo on the side. I don't know if you could see that very well.
Oh, yeah, there it is. Nice.
So you could print off this whole thing. I just built this under there because I didn't like the little box on the side, like all the rest of them have, and it just came out beautiful. So I went into there, rewired it, did the right things. You know what I mean? I put in all these things on the top that are flat. So it's kind of dusty because I haven't worked on it in a while, but it runs beautiful. When I first got it, the power source was bad. The head was all clogged. It was just nasty looking. So I took it, fixed it. I got a bunch more stuff to put into it. I just have been busy lately.
That's cool. You know what? That's the CR10, right?
Yeah.
Yeah.
So it's 300 by 300 or 1 foot by 1 foot for the bed size.
Oh, yeah.
So
Okay.
let me give you an example. Let me pull off my headset real quick.
So you could do like larger pieces kind of thing.
Come on.
No worries, Nathan.
This right here,
Yeah.
that's about the size it can print out. You see next to my big fat
wow.
head? No
That's
problem. This right here, 4 hours. That's it.
4 hours.
4 hours. This is the bottom for my Tesla coil that I'm building.
Yeah.
It's a 3-inch wide tube. So you can see right here, the number 1 coil goes right on this. Okay. Number 2 coil goes down in the hole. Comes out the bottom. You're able to do it. This one didn't cut out, so I'll have to rebuild it. But usually I cut them out so that it can slide right down to the side. I think there's a bottom piece on this. That's what it is. There's a bottom piece it sits on. So anyway,
that's a good size. That will, yeah.
But anyway, it'll get you started, and then you can start building whatever you want.
Yeah, that would be nice to build whatever I want. I'd go 38 feet diameter. No, I'm kidding. Where am I? I'd love to build whatever I want, but that's awesome. You know what? That's my next purchase. Is going to be a printer. Yeah, I'll probably end up doing that tonight because there's a few things that it would help me finish.
Yeah.
Yeah.
The only thing I'll tell you, if you want to print ABS, make sure you have it encased. A simple box would do it. Any wind that comes by, it makes the print peel up.
Oh, really?
Yeah, just on the corner.
Yeah.
So usually on a couple hour print, it'll peel if you do not have it encased. So.
Oh, you got to see this comment.
Huh.
Nat, man. That's what you should have on the side of it. That's great. Yeah, that's great.
Well, it kind of fits my room, doesn't it? I got a bunch of Batman stuff. I got Spider-Man, you kind of have that stuff. So
Spider-Man was my hero growing up. With great power comes great responsibility.
Yep.
That's a big deal. So yeah, 3D printed. Freaking A, that's my next purchase. That's what I'm doing. Because then I can finish something. In fact, I wonder if, I don't know what material I could use in a 3D printer for this, but if there was a way of building like the form for building my coils and just sending the file to people with printers, then they could build the form and then, we can do the tutorial and people will know how to do it. It's just a thought.
I'll see if I can't pull this up while we're talking. I use Fusion 360. Okay.
Yeah.
For all of my CAD designs. So nice. I get on there, a couple hours sitting in here, having some coffee, listening to a little heavy metal and rocking it out. So
yeah,
just give me a second to load it up. And I'll just show you some of the designs. I built a ion thruster on there.
Yeah.
So, and I'm able to put out the STLs for that. All kinds of cool stuff.
Oh yeah, you know what I want to build? I want to build Jay's plasma knife. That thing's beautiful.
Yeah.
Printer would help with a lot of those things, I guess, eh? Now, is there a printer that, and I know there is, probably pricey though, that's like lengthwise rather than square? So say 3 feet long by a foot wide or some crazy thing like that. Do they have those out there?
You can build that. Generally, they do not sell them that way.
Okay, that's fair.
So I'll show you here. This is like a kind of a first look, and I wish I had it all cleaned up, but I'll share it anyway. Let me hit the present screen on here. And I don't know.
No present.
There it is. Take a look at that. That's my Tesla coil that I'm in the middle of building now.
That's nice.
Tell me what that looks like.
That looks like an Egyptian, I can't remember the name of it. It's on a hieroglyph. It's attached to the bulb on the hieroglyph. I just can't remember the name right now. I'm sorry. Gapping it.
Exactly right. So
yeah,
that's the one I'm building right now.
So are you wrapping in between the discs, or are you wrapping underneath and using the discs as a?
So this one right here, I had started this before Sean did his, right?
Oh, okay.
So I wasn't going to steal his secrets, you know what I mean, and use them on my stuff. So
I get
this one right here. It slides over the top. It's a basic Tesla coil. It's all DC. It's a Slayer exciter circuit like you just saw.
Yeah.
The difference is going to be I'm going to push this sucker out about 6 feet on each side.
I love it.
It's going to be like it's going to look like a lamp in my room, or just, you know, something like that. And then I'm going to turn it on, and it's just going to freak you out when you got a light bulb in your hand. I'll probably have the wife grab a light bulb and come in. You know what I mean? That
will be cool. You know what I'd love to do if like so will that work on your printer? That's
that's what this thing's for right here.
Oh, okay.
This is the bottom before the sleeve goes over the top.
Yeah.
I haven't put the Egyptian symbols on it yet.
I want to copy it when you're done. That's awesome. I want to attach it to some sort of bulb or something. I have a bunch of 1,000-watt HPSs I can attach it to, or even, I don't know. I got some metal halides, but they're different.
So this is my ion thruster right here.
Oh yeah.
So you can see it's thicker in the bottom. You could just stick a tube right through there in each one of them. And each one of these tiny little holes is the wire that goes in.
See, so I need a printer. I'm going to just say this. One of the reasons why I really want a printer is because what you designed there, or that ion thruster right there, I have a design for the way that the wire will go. I don't know if it'll work, but if it does, it might actually give you more ion wind with my design than the way people have been doing it for the last like 10 years. I don't know. I could be totally wrong, but I won't know until I get a printer. So that's awesome.
Yeah. Oh, hold on. Let me pull one more up, and then I'll stop sharing it. If I could find it real quick. Was working on something.
I used CAD in the beginning when CAD first came out. It's been years since I've used it.
Yeah, let me see.
I don't think it'd be too hard for me to pick up, though.
Oh, hold on. This right here, I'll show you this one, because this is almost like a coil winding spool.
Yeah. That's kind of what I need for a template.
This is something totally different that I actually burned up and blew up, by the way. I tried to make a Corona motor out of it. Let me just tell you, I'm not an expert in a Corona motor, not at all. And I actually just put high voltages in it and set it on fire.
We can't be experts at everything. We're lucky if we can get to be an expert at one thing, right?
Yeah.
So we can dabble in everything, but being an expert, man, my brain would explode with that data. So yeah, but this is a good idea for templates. That's kind of what I was thinking.
This part goes on my Tesla coil right here.
That's the sleeve, or
that goes over the top portion. So where it looks like the AC flyback.
Oh yeah,
actually the portion that goes in between them, so it looks just like the Egyptian one.
Oh yeah, okay. Yeah, I get that.
So I could color it different colors or whatever, you know what I mean, based on whatever you want to put in there. And then we could clean it up and paint it. I plan to paint mine really cool color. So
yeah, because you can paint whatever you print, right? It's
yeah.
Yeah.
It's just plastic. So all you got to do is take a little filler, put it in there, and then paint it up. Yeah. So I'm not seeing the one that I wanted to show you, and that kind of sucks. I don't know why. Oh, dude, I got a ton.
Yeah, you got a list.
I used to build fans for my computer, the little covers for them.
Yeah.
And that's what I generally do this with. So that's why everything else is fairly simple.
I was watching a channel. I can't remember his name. If I did, or if I could, I'd give him a shout out. But he was using his 3D printer to build different shapes of blades to see the efficiency for PC fans. It'd be an awesome thing to try just to get to know how a 3D printer works. Well, that's killer.
This is my plasma axe. So I actually built this thing. Okay, check this out.
Really?
So the part you see right here.
Yeah.
You see it?
Yeah.
They actually had real plasma coming out of them. So it was 10-inch saw blades that were cut down, and I put them in there and stacked them. And then I put a actual wire on the outside, and it would blow plasma the whole time, man. It would just fill up your room with all kinds of stuff. You know what I mean?
Yeah, I do. I totally do. You couldn't run it for long, I imagine.
Well, no, only for a little bit. I mean, they won't let me go out and LARP with it, so I don't know what to do with it to scare people off, but it was a really cool build.
That's a Halloween LARP. That's
Just kind of turn it on every once in a while and freak people out. And it looks better the more nighttime it is, it looks even better.
I have an idea for a plasma sword. That's why I brought up how a 3D printer be longer. But we'd have to build a special 3D printer, and I don't even know if it would work. But if it did work, it'd be a cool build. It would be like everybody would want the design.
I could tell you right now, they build 6-foot swords with a printer my size.
Get out.
No, they have a special glue they put in between them, and it works perfectly.
Really? That gives me
I got to start putting titles on things when I go in here.
Yeah, I have that problem too. I got a whole bunch of files that are just numbered, and then I forget what's what. It's horrible. I got to stop doing that myself.
Well, there was a really cool. Yeah, sorry. Go ahead.
No, I was just going to say it takes 2 seconds to rename it. I don't know why we don't do that. But what were you saying?
Oh, nothing. I was just saying I was trying to present that frame I was showing you earlier. The last time we talked, I had it in here. I don't know where I put it. So it's all good.
I hear that.
I'll do it someday.
Desktop with so many files on it. Oh man, I gotta clean. Gotta clean my computer. It's one of those things. It's the last on the list, right? So much going on. It's like, yeah, I'll get to it. A month later, oh, my computer crashed. Oh well, it is what it is.
Hey Gerald, I have 3 computers. I have. This is the only one that's on any kind of network, and the rest of them store data. That's the way to do it. And they only pull from that to go to here and never backwards. So
yeah, you know what? The way that I do mine, it's always offline. I get my data and I put it on my other computer. It never sees online. There's no cables near it whatsoever. But I only use it to access my drives. I've got a whole bunch of external drives equaling like 5 terabytes. And I just swap the drive out. I know what drives for what. It's all labeled. And yeah, no one's touched my data. You have to come to my house. And
you got to have some hidden information somewhere. You know what I mean? So
you can all do it. I learned a long time ago when I started with the scientific community, because there's trolls everywhere, they know it, everybody knows it. And I got hacked and I lost a computer and a bunch of data. And ever since then, I'll never allow it to again. You hack me, go ahead. What are you going to get? Nothing. I don't do nothing with this computer. Live. That's it. Or I'll put out a video. That's it.
Yeah.
Yeah. It is what it is, right?
Yeah, it happens. It's,
Yeah.
I mean, if you learn Hello World and start talking to a computer, I'm sorry, you're going to learn how to do it whether you wanted to or not because you understand the software. So,
yeah,
it's just part of life. No matter, there is not a good program that stops everything.
No, there's some good ones. If you get a few programs, you can actually mitigate a lot of different attacks if that's what's going to happen. But unfortunately, it's the internet. It happens. It's not perfect, but it's good. It works. Shout out to YouTube. No, I'm kidding. I'm kidding.
Hey, Joe, you got those circuits you were showing me earlier that you had built?
Yes.
Why don't you show those?
Give me 1 second.
Yeah. Joe's got some cool circuits that he had built, and he put it onto plexiglass. They absolutely look beautiful. I want to make sure he showed them out to everybody. Yep. And by the way, I did get hacked, and they got nothing. So good luck for all them. What did I say? To a huge 3D printer? I had two 400 by 400s, and I got rid of them. They're just too big for my little garage, unfortunately. I didn't have the room to keep them. But, yeah, I could do a video on it when I do my Tesla coil one. I'll show you kind of behind the scenes of Fusion 360, and you all can kind of get a look at everything that I did to build it. And then that way you could do it on. And then I always throw all my files on Thingiverse. So I usually leave a link in the description. You can pick them up, print them, do what you want, fix them, make them better, however you want to do it. But I always do that for you guys. All right, Gerald, floor is yours.
Oh, I don't want a floor. That's a lot of work. I'm a jerk. I don't do that. So, all right, this is the first circuit, and this is a horizontal. So this here is a horizontal deflector transistor. And I'm trying to figure out exactly how the wiring is because I got it all fandangled here. Okay, so we have our base, collector, and emitter. Our base goes to here, and then this is the negative, which goes to the emitter. These are used for my function generator.
Okay.
And then I have my collector. Let me think about this for a second here. All right. So my emitter again goes to the other black. And this one goes to. Hang on a second. I'm going to think about that. Right. That's the power. So we have our positive and our negative.
Mm-hmm.
The positive goes to the collector, our negative goes to the emitter, and then I use the base for my function generator's positive and the emitter for the negative. This over here, as you can see here, this is where my bifilar coil system goes into. So on my primary input, my primary output, my secondary input, my secondary output. And what I do with my secondary, what I put was 2 posts. So it goes to this, which is actually a spark gap. It's a contained spark gap. I can't remember the number of the part, but it's acts as a spark gap on my secondary. And from here, I can tap it and put on a cap bank or a hairpin circuit, which is what my system loves to use.
Okay, real quick before you go on.
Okay.
Have you ever tried putting music in where you put your frequency generator at?
Absolutely. But the problem with that is I need to use a special circuit to do it because otherwise it shuts off my amplifier every 2 seconds because it feeds back in. So when I use that circuit, you know what? I will build that circuit for you next week on video, and we'll show it.
Yeah, because Ben has the same thing going on in his, right?
And I wanted to talk about Ben about that, but you know how we get into discussions and things flow, it just kind of slipped out. So I have a circuit that will stop his amplifier from blowing or from shutting off from non-automatic cutoff system. And we'll go over that circuit. I use a 13, it's an E130009LE. It's a MOSFET, I believe it is. I believe it's I believe it's a MOSFET. I have the circuit. I'll show it and we'll do that. This one, go ahead.
Hold on. Just make sure you have the parts because, Gerald, I'm going to tell you right now, I'm going to build that. I'm sure there's a lot of people in the chat here are going to, they're going to build that one. So if you got a diagram, make sure I get it. I'll post it.
I will.
Or put it on your, put it on your channel.
I will.
And put the diagram so we can all go over there and check it out. And
Absolutely.
then once we do the next week's show, put that one there too. So I think honestly that's what we need.
Okay.
And I'll put up mine as well.
And this here, this transistor, this is a 1600 volt, 30 amp horizontal deflection transistor out of an old tube TV. This one really, my coil loves this one. Puts out a lot of juice.
Do you have the model number on there?
That one is a D2499. Did you catch that?
You said D2499?
Yep, transistor. Pretty sure that's the 30 amp one. It might be the 15 amp one. No, I'm pretty sure it's the 30 amp. Correct me if I'm wrong.
Well, I'm sure they'll pull it up, so they'll definitely know.
I don't mind being corrected. I make mistakes, man. I'm human.
Hey,
I ain't perfect.
I'm there with you, bud. All right, what do you got? What's the next one?
Okay, so the next one, this one's a little bit more complicated. We'll have to go over this one in a video. See if I can show it properly to my camera. So this one, okay. Like I said, it's a bit complicated, but my bifilar coil goes in this. I use another speaker clip, right? So my primary goes in the top. My secondary goes in the bottom. This is a transistor for the first signal out of the signal generator going to the primary. This is the second transistor from the signal generator that goes to the secondary. When I pulse that coil and levitate it above a magnet, this is the circuit. So first signal turn on, it'll be this transistor. The coil will go an inch above the magnet. Second signal turn on this other transistor, and it'll go an inch and a half to 2 inches above the magnet.
Nice.
Then I flip this switch and I turn this potentiometer, and from that point it jumps the third time and raises or lowers depending on the potentiometer setting. That's what this circuit does. This, if you're wondering, is the power. I just hook this up to whatever power I want. A battery, a wall plug, whatever. So the neons that are in here are in case I put too much current through it, they automatically turn on and they use some of that load so that the circuit stays cool. This is a 50 ohm ceramic resistor that's needed with this 1K potentiometer, or you're going to blow this potentiometer through the roof, which I've already done and had to replace twice, and I'm on my third one. So we'll go over this circuit in the next video, and I'll do I'll do a full build live on this one, because this one's kind of it's not complicated, but it's really neat, and everybody should use it in their bifilar coils.
Absolutely. So Ian says, is that your modified Joule sleeve circuit?
It's part of it. There's a little more to it that I can't add to this circuit because there's not enough room on the plate. But it's pretty much the modified Joule circuit. except for this part. This part's usually got a hairpin circuit instead of the resistor, and it goes to a cap bank that I tap for a load. And that's kind of how I control my primary through my secondary.
Nice.
Yeah. So we'll go over that. And because of what you've been teaching me, Nathan, it's not just a bifilar coil.
Okay.
It's a geometrical bifilar electromagnetic bipolar resonant coil system.
That sounds like too many big words for me.
It's freaking full of baloney, but it is what it is, right? It's literally, if you were to describe it, that's what it is. That's not what I'm calling it. I'm calling it something else. But because everybody gets to name their system and blah blah blah. I'm calling mine Imagine. Not
nice.
Imagine. Magine. And I'll tell everybody what it stands for next week.
Gotcha.
They're all short.
Oh, yeah. I love doing this because everybody's going to be building all these circuits as soon as the diagram gets out there.
Yeah, I hope they do. And I hope they pound out their systems and make it all work. That's the more experimenters, the better. I wish you all mass amounts of luck. You know what I mean? And I will get the schematic for this one out and schematic for this one out. And I have a few more really simple circuits that you guys are going to love. But I warn you, I'm not the greatest circuit builder. It's just the stuff I've used. Let's see, where's that little book? I have a book of circuits. Every circuit that's in it, I've tried, and it works. It didn't go into the book if it didn't work or I didn't try it. So there's about 30 or 40 of them in there that are pretty simple. Yeah.
We're going to all be busy building Gerald circuits. I just make sure you put all the part numbers in there so we can order everything.
And don't kid yourself. Half of them aren't my circuits. Half of them are circuits that were built and used in other systems that I have used that work. So I'll make that very clear, and I won't. The circuit that I put out, I'll tell people this isn't mine. This one's Bedini's, or this one's, you know what I mean? This is a modified Bedini. I give him credit for that. Guy's a genius. But
very nice.
Yeah, so we'll get her done.
Sean asked a question. Have you measured the watts in and out?
Yes. In fact, the reason why it took me just a little bit to get this circuit to show you guys, I said, wait a minute, and I went and got it, because I had it hooked up, and I was doing some tests just prior, and I used my Variac because I wanted to test something.
Nice.
The more volts I put into the circuit, the less watts it takes to run the circuit.
Nice.
That makes sense. And I had it hooked up to a watt meter, and I was levitating the coil above the magnet at 5 watts, 35 volts. And the more voltage I went up, the wattage would come down. So go figure. Yeah. And that's, I'll do a video on that and show it maybe tomorrow or the next day. Yeah. As soon as I can. I'm a little swamped with work right now.
Yeah, it's not a problem.
Yeah, I got to work to make money to build this stuff. So that's what I do. Right?
I think we all do, man. We all put a little extra on our backs to get this stuff done and get these things out there.
Part of my fun, man. Part of my joy. I love learning. If I blow something up, I've learned not to do it that way.
That's right.
Yeah, like your saying goes.
I will say this to anybody out there who wants to come on here and show their circuit off. It's small circuits. We're talking, maybe 10 parts, 12 parts, you know what I mean? Maybe a little bit less on the circuitry part. And I'm not talking about, where they hook into, the speaker outlets or stuff like that. That's not what I'm talking about. Just, simple parts, the transistor, the MOSFET, whatever you got, things like that. Absolutely love to do them. If they're going to help everybody in this whole community build them, let's do it.
Yeah, this is just me being lazy, putting in the little speaker clips.
No, I love that.
Mess around with the wires, so you're right.
That's why I always solder the end of them, and put them into things because I hate that fraying wire because I have to strip it again a few weeks later.
Sitting there twisting it all the time drives me nuts. That's why I use those. I strip them out of old speakers, some car stereos, or wherever I can get them. Old house speakers, you name it. Yeah. That's what these are from, right? These are from house speakers, these little posts. Nice. So repurpose everything you can find, guys, and make it easier on yourselves. That's the best.
I got to get myself a little crimper for putting on those little end pieces. You know what I mean? So that they can go into those little things or all that other stuff to crimp on the little fork ones.
Yeah, the banana clip ones that they just pop in. Yeah.
Dude, I'll be honest with you. I stripped that stuff off, that plastic. I hate it. I hate usually smashing the stuff. I always solder everything together. And it because of the voltages.
The circuit works better when you solder it together. I have so many different coils. I'm constantly swapping coils out to see what circuit works best with what coil and configuration. So I never end up soldering. That's why I try and make it like where you can constantly ship parts out, right? Makes it look a little more complicated though, but yeah, you know. But you're not wrong. 10, 12 parts, well, 8 to 10 actually, I think is probably the best. Make it simple, and you know, anything more than that, you're including op amps and you're trying to get into like 555 timer chips and all of that. It's good, but it's too complicated for us. We just better use a function generator and a simple circuit.
Yeah.
We want to keep it simple, right?
Absolutely.
Yeah.
So that's kind of the goal. So if you guys want to come on and do it, you're absolutely welcome to. And you just got to hit me up on my email on my page and drop me a line and let me know that this is what you want to do and show us. That way the whole community grows. You know what I mean? I want everybody to have circuits that they can use for their toys and, you know, whatever they want to build. And, you know, we'll take the stories with it. You know what I mean? Pre-tape yourself building this thing, man, and then come on and show it to us, kind of like we did today earlier. And then if you blow it up, that's great. We'll see that. We'll talk about that. You know, because I have plenty of those videos where things explode.
Nathan has the saying, fry it and find out.
Yeah.
That's how it goes, man. Hey, and that's just learning. You learn not to do it that way.
That's right. I have a whole box that goes out to the trash every week that's blown up. Yeah. And unfortunately, because I work with static electricity a lot, I have more that blow up just on the side from sitting there. So sometimes I'll get it to run through something and I'll blow up a whole bunch of transistors because I didn't realize it was over there. That's why my whole workspace is on one side over here for all my transistors to hold. My workspace to build them is on this side over here. Because
I have a storage room that's off to the left and behind me, and I have a metal wall. It's like a series of shelves, but I grounded out the wall because, like you, I had a bunch of stuff on it. I wasn't even thinking. I had like a car stereo, and I had, I don't know, a bunch of crap. And I'm doing experiments, and I went back and I'm grabbing pieces to put into things, and they're not working. And I'm like, what's going on? And I figured it out. I totally zapped everything on the shelf, so now the shelf's grounded out. Nothing gets past. Yeah, so I store stuff on that in that room now.
I had a transistor, literally, man, a 1-inch spark was blasting out of this thing. It was on that Tesla coil, man. I was trying to ramp it up, right? And I go, well, let me put my variac on it. Okay. So I go and I turn this thing up, man. The next thing you know, it starts humming, and I go, oh, I better turn it down, right? So I reach over to turn it down, and I just get a big blast wave that comes out. So a piece of the transistor came out, and this 1-inch spark, man, just, and I'm going, oh, well, there goes that one.
Yeah, that one's gone. I've heard POWs with transistors. They go bang, and then there's like a big chunk missing, and it's like, what the? That's funny. Oh, there's a comment Sean threw out there that's just awesome. Look at this. Trailer park coil. You should do an episode. I love it, Sean. That's great.
That's great. My God.
He asked a question.
Go for it.
Where is it now? He asked how to show. Oh, here it is. Can you explain a little on the circuits or how the circuits are interacting with your coil? Now, who are you asking? Nathan or I or both?
I think he's talking to you.
Okay. Well, it depends on the circuit, but the modified Jewel Thief, right? That circuit, how do I put that? I can pull resonance out of it and I can charge about, I don't know, I had 10 batteries charging at one time on that circuit, and it charges it really slow. And I can also levitate a coil above a magnet with that circuit, and the coil stays absolutely cold. So it's more like a low-level experiment circuit, this one, the modified Jewel Thief. Whereas the horizontal deflection transistor, that's power. You're using, this is for power, right? The more you put in, the crazier the effects on the coil gets. Like I can't put, when I use this, I can't put more than 30 volts through the coil or I have problems in my room. So don't try this at home, folks. I think it has a lot to do with the geometry of the coil and how I wire it when I use it in the circuit.
Yeah.
So, yeah. So that's kind of how they affect the coil, but every different circuit affects the coil differently because of the rise time and the fall time.
Mm-hmm.
So rise time being the quicker the pulse in, and fall time being the speed of the pulse out. When I have a really fast rise time, this thing does crazy amounts of power coming in and out. I've blown meters. I've blown a function generator. I even blew an oscilloscope, old Technotronic doing it.
Oh, wow.
So, yeah, it's a little bit insane how some circuits will push power through this coil. Others, just, it's subtle. You know what I mean? Just a nice subtlety, and I'm able to pull the power out and throw it into multiple batteries all at once because it's like a slow pulse that builds. Whereas the horizontal deflection transistor, it's like Thor's hammer shoving it straight up your, like it's insane, okay? I'm just saying. I'm sorry for the terminology. I'm just one of those crass kind of guys. But yeah, it's that's kind of, does that answer your question, Sean? That's kind of what I was getting at with it. So
yeah, I think that was Ian that was asking that. I think he's asking specifically because he's building coils like yours, so he's trying to figure some stuff out. He actually had questions for you last week on some of the stuff because he built this beautiful round coil, and it was like a donut shape, and it had little knobs on the end, and he had a coil that looked like it wrapped on the outside, and then ones that went inside the actual donut shape and back around. You know what I mean?
Yeah.
But it was really cool. I'll have to, you know what? Give me a second. I'll pull it up. If you want to talk about one of the circuits, I'll pull it up real quick.
Yeah, for sure. Talk about one of the circuits. Well, what other circuits can I talk about? Oh, I did work on a circuit that involves the coil where I pulse the primary and the secondary, the input of the secondary acts as an open antenna. You just leave it open to the air. And the output of the secondary goes to a cap bank, and then from the cap bank to the ground. And when I do that, I hook it up to my copper pipes in my basement. And if you take a circuit hooked up to my ferrite core and you walk around the house and you touch the ground wire to any of my copper pipes, you're going to create voltage, light LEDs, maybe even charge a small battery, and it goes throughout the whole house. So that circuit is part of the coil, but it's not on a board. It's just a simple circuit like this, but it's not a horizontal deflection transistor. I can use for that. I could use a 2N222. I can use a 2N3904. There's a few really small circuits I can use. I can even use a Darlington to make that happen because of the way that the secondary is set up. So that's something we can get into in the future when it comes to grounding. And as I said before in a previous live, I figured out how to use water as a ground. So that is related to the circuit I just explained when it comes to my secondary.
All right. Hold on. You can't just say water to ground. You got to give us a little more there, Gerald, because people are going to be dipping wires and stuff. And unfortunately, no, we don't want that.
Everybody should know it doesn't work that way. You kind of have to have a system that squeezes the ether or the quantum vacuum and allows energy to flow in a certain way. My secondary is like a back EMF system that's always in resonance. So when I take my output of my secondary and I run it to a cap bank, and then I do one other thing that I'll leave out because I want to show it live.
Okay.
I do one other thing, and then after that one other thing, the line goes into the water, and then I can use that water if I was to have a stream or a long, say, even a tube of water. I can transfer energy through that tube to the other system using that water as a ground to connect the two. Does that make sense?
Absolutely makes sense.
Okay. So I do want to do that one on live, but that's maybe a couple episodes into our circuit build and stuff.
That's fine.
That's that one I'm waiting to show some of the basics first before I get heavily into it. But it's a simple circuit when you're using your back EMF.
That's going to be amazing to see, to be honest with you.
You know what? Once you see it, you can never unsee it. And I think everybody in the world should use it because I believe it cleans the water, but I can't prove that yet. It's a theory that I'm working on. Okay. So, yeah.
So let's check this out. This is Ian's coil right here. Hold on. Let me get a good picture for you. Oh, that didn't show it. Let me just hit play. Oh, here we go. Sorry, give me a second. Let me turn up the volume for you.
Yep, no problem.
Yeah, I think it's still a menacing's way. So he says it makes it a better movement. Anyway, so I thought I'd just, so for every winding, there are 1,104 turns on each node.
Can you show that up to the camera real quick?
Yeah.
Everybody can see it.
20, the 24 nodes. I numbered them on that side so to stop me getting lost as I usually do. But
is he live?
It almost looks like a Mandela.
It kind of looks like an eye.
Yeah, or an iris.
Well, the distance, an eyeball. Yeah, but I haven't done. I built Gerald's when Gerald was on with us a couple of weeks ago. He gave us that circuit. There was kind of a Bedini style circuit where you're impulsing the battery with the negative impulse.
Yeah.
Basically, the back EMF, the discharge from the coil. And I got, but I couldn't get any usable resonant frequency out of this that would work within that system. But this one I did differently. Again, I'm playing around here, and there are probably huge holes in my knowledge compared to what Gerald knows. But I keep trying to associate the ratios of either the geometric sides or angles with the diatonic scale. So if you've got between the square and the triangle, it's 4:3. Hexagon to a triangle is 2:1. That's an octave. 4:3 is perfect fourth. And then you've got 3:2, which is the hexagon to the cube. That's not the cube, the square, and that's your 3:2. And then obviously the octagon on top. I like the octagon because it progresses in threes on the nodes. naturally. So that gets me into my mod 9 as well. But the octagon is obviously 2-to-1 to the square. So the problem is that when I started winding it, I realized that I was losing the angles because of the rotation around the actual. Because what I was doing was coming, say, starting from, where's the start? There. So start here, you wind around, inside, and then out to the first node, which would be 8 for a triangle, then winding back in here. So you've got a 360-degree rotation, but it's reversing, it's doing it in a helical pattern. But rather than closing the actual circle, it's then reverse winding and coming back in the other way. And then once you do one full round, then reverse that completely and actually wind over that winding as well to try and get this sort of effect. But I haven't had a chance to do anything other than that Gerald circuit today, which it didn't do anything. It's still a nice ornament.
It's interesting. It looks like the field geometry.
Okay, Gerald.
Yes. I'm just gonna put my cat. Come on, Sylvester. Yeah, that's gorgeous, actually. Good job, Ian. I didn't get to see that. I don't know why I missed that part in the video. Maybe that's towards the end.
About the middle, right around the middle.
Yeah, I probably skipped it because I was jumping a little bit. But that's a gorgeous coil. Like, I would suggest he doesn't use the modified Jewel Thief, but he uses this regular pulse circuit, the one that I put with the horizontal deflection transistor. It's a very simple circuit. I got to get the schematic out for it. I would use a positive pulse on that one. But I don't know how it's going to react because of the way he wound it. Because he went back on itself.
Yeah.
In a way. See, I don't wind on round toroid forms because it changes the whole geometrical form of the coil and the ability for energy to move in that way. Energy is moving different in that coil, more like a interference pattern rodent coil, if that makes sense. Yeah,
absolutely.
See, I use constructive interference, but when you're crossing it, how do I explain that? My lines get crossed, but they cross 180 degrees out of phase. They don't cross for the sake of crossing.
Yeah.
Yeah, so it's hard for me to explain how that works, other than if you are doing it 180 degrees out of phase when you're crossing your lines, they act differently than they do, say you wound a coil on a form this way, and then you wound another coil on that same form opposite. That's just going to cancel each other out.
Right.
But I don't know. I wonder if he pulsed that positively, if it would act different than what he's getting now. Because this circuit, and I should make this clear, it's probably something I didn't make clear. This modified Jewel Thief circuit, when it's pulsed, when I use this circuit, it comes off the negative side. This is an NPN. This is a 2N3055. And it goes from the negative side of the power to my coil, then from the coil to the circuit.
Okay.
So when it's pulsed, it comes out the back end of the circuit through my coil before it goes anywhere, rather than pulsing it into the primary with a positive pulse. It's like sucking it through the back end. Does that make sense?
Yeah.
So maybe that's
here's what he said right here. That's what he was aiming for. The 180 degree turn was to get the 180 degree phase out.
So I wonder if it's just the way that you wired the circuit to it. The circuit may not work for your coil. I'm not going to lie to you. That's what I use for my system. But if it does work, try it on the negative end of your power supply rather than on the positive, right? Because there's a difference in that circuit. I'm not sure if I made that aware when I was explaining it. So Ian, if that's how you had it set up, then maybe we have to try positively pulsing your coil. If you didn't have it wired that way, try it so that it goes from your negative of your power supply to your coil, and then from your coil to the negative of your circuit, and try pulsing it like that. And that might work. Because that's what I do. So, but again, not every coil works with every circuit, like you said, right?
Yeah.
You have to play with different circuits in your coils to get the system properly running, because coils have construction interference and they have destructive interference as well, and you have to figure out which in order to use the right circuit to kind of pull your energy out.
That's right.
Yeah.
Huh.
So if that answered your question, it was long-winded and I apologize, but there it is.
It's all good, Gerald. Yeah, hold on. He said, yeah, thank you. That did it.
Okay.
Good.
Okay.
That's what I did. I'm reading the birds backwards now. Okay.
Did I?
That's what I did.
That's, see, I did it backwards too. That's hard to do, man.
Sometimes, man, I just wonder.
Yeah.
So.
Yeah, you know what? If that didn't work for you, Ian, like I said, pulse it through a different circuit. Positive pulse might be the thing.
I think Ian's going to be watching your channel for your circuits there, Gerald.
Yeah.
Ian builds everything. Let me just tell you that right now.
Good.
If you show it, he'll build it.
Good. Prove me right or prove me wrong, please.
That's right.
Either way, prove it for me. Because, I don't mind being proven wrong. Just means I go in a different direction. That's all. I don't think you're going to, well, maybe. I shouldn't say that. Yeah. But yeah, you know what? I wish my little book was here. I'd show you another circuit that might work for you, but I'm not sure where it is right now. Oh.
Sean says, what's success look like? Well, I can only tell you 50% of the time. Some days it's only 10%.
I was going to say, I don't know. When I find it, I'll let you know.
Yeah.
I'm still working on it. Oh, man.
Oh.
Let's see. For that one. Yeah, like this is a very simple, regular pulse circuit. I don't know.
Okay, can you click it?
I can hold it straight there. Just a regular pulse circuit, right? This is your battery. And then if I can hold it straight. I'm drunk. No, I'm really not. I don't drink. Sorry, guys. I suck at holding things to cameras. But that's the circuit I think you should use to pulse your coil, Ian. So I'll do a video on this, and I don't know what to use to draw it. Maybe I'll just draw it on my board and get a close up so you see it. Maybe that's how I'll do the circuits. Yeah, would that work?
Yeah.
Okay, then that's what I'll do. Yeah, and I'll put it on my channel. I'll do a video about it tonight. I tried putting a video out before we went up, but for some reason I went to go put Ben's name in the title, and I don't know what the heck I did wrong, but it didn't put it in, and I put up the video. So I took the video, I put it on private, and I'm going to put it up again with his name in it because he's in it too, right? So I like doing that.
I think if you just show the diagram like on the board and then give a brief explanation of what it's doing and what it's for, perfect. I think
you want me to do a video on that, or you want me to do it now? You don't want me to do it now.
You can do either one. It's fine for us.
Okay. Let's see. I got to find it again. All right. See how fast I can draw, guys. Don't count on it being pretty.
You got a transistor or MOSFET on this one?
This one's just a regular transistor. You can use almost any transistor for this. Go ahead.
Nothing. I got a bunch of those. So what do you got?
Yeah. So I'm not going to make a mess here. All right. Yep.
So Ian says, okay, great, thanks. Yes, and a brief explanation of what the circuit is doing. Yeah, just like we said. Oh, man. Huh. A lot of people are having fun in the comments. I can tell you that right now. Huh.
Yeah, they're laughing at me trying to draw. This guy sucks. What the hell?
I got to watch what you draw because sometimes, man, it doesn't come out right.
You're going to tell them the story? Maybe you shouldn't tell them the story. I suck at drawing, everybody, just so you know. I drew a circuit. I won't tell you what it looked like. But I drew it and I showed it to Nathan. He lost it laughing, man. I suck at drawing, okay? Let's just say it didn't come out very good. It looked like something it wasn't supposed to be.
Oh. Yeah. That was funny, man.
I laughed about that. Man.
Hey, I kept doing the same thing. My wife comes out. What are you doing? You know what I mean? Oh, I'm just writing something down. I'm halfway through writing it. And she's like, what are you drawing on there? I go, it's just a circuit. It's nothing else.
But it looks weird if you do it wrong. Okay, let's see if I can show this here.
All right, let me put you on the solar thing.
I
And
have
you're
to
ready to go.
raise the whiteboard. I don't know.
There you go.
Let's see. Okay. So, power source, battery, the positive goes to the collector. The negative goes to the coil, right? Signal generator, positive goes to the base, negative goes to the emitter. Now that I used for a regular pulse, but I drew it wrong because I was drawing. I know what I did wrong here. I apologize, everybody. What I drew here was the circuit with a horizontal deflecting transistor. And I will just change it really quick so that you see what I'm talking about when I mean positive pulse. Brain fart. Sorry, everybody. Okay, so yes. It's like this. Like this. Let me fix that.
You're still thinking about that circuit, aren't you?
No, when I drew it.
Oh,
Right?
did you do it again?
Not really, but kind of. Oh, it's horrible. I'm a horrible person. I apologize, everybody. All right. So, signal generator, positive goes to the base, negative goes to the emitter. The battery goes to the coil, then from the coil to the collector. And your negative on your battery, of course, goes to your emitter. And that completes the circuit. And you can pulse your coil positively that way. That's where I made my mistake at reverse. Sorry, everybody.
Now, just so we know, those two lines that look like they cross over on the E, yeah, right there, they hop over, right? They're not.
Yeah, they do. But you know what? When I just drew it, it looked wrong. You want to see? When you draw a circuit, as everybody knows, you got to hop over the lines, right? So here we go. We hop over the lines. Do you see my point? So I just drew it straight, man. That's what I'm saying. Like, and that wasn't intentional. It just
That's
is
almost
what
as
it
bad
is.
as the last one you did.
You get what I mean? Man, drawing circuits. I suck at drawing. What can I say? So,
Don't leave that on there when your wife comes in. She'll be wondering what you're really drawing.
that's why I wiped it out. Oh, this is killing me. That's hilarious.
Oh,
So Ian, if that helps, that's that's where it's at.
oh, it's so great, man. It's so fun building this stuff with people. You know what I mean?
You gotta have fun. Life's short, you know. Like you never know when your last moment's gonna be. So laugh and enjoy, man. That's why I love learning. That's my joy. I love to learn. And when I do stuff like that, I learn not to do it that way.
He's taking the long way around the battery to put it up there so he can show it. He's, I don't want to show that.
That's why I do. Oh man, I'm not gonna get. Like I said, I suck at drawing, right? So get myself in trouble that way.
Who said you can't have fun building circuits, man?
Right? Well, drawing them at least. You know what I mean? Dang. So yeah, when I do schematics, I'll do my best not to have stuff like that show up. But don't count on it.
Oh my god.
Oh, check this out.
Dude, that's so great. Oh.
Good one.
Oh. Oh.
Man,
Oh.
have fun with it, right? Have fun with it.
Oh, absolutely, man.
Yeah. Life's too
Oh.
short. So yeah, so next week I got it noted. I've written down here. I've got to we'll go over this circuit live, the dual modified dual theme. And then what else do we have to do for next week, or that I have to do for next week? We just went over a whole bunch of laughter and it all leaked out of my head.
That's it, man. We're
Right
gonna
on.
the Ben checking in and saying, yeah, he's laughing it off, man.
Good. That's good. I hope you're all laughing up there.
So
Yeah.
I'm gonna bring my own circuit, man, next week, and it's not gonna have it's been drawing.
Yeah, you're not gonna draw it like me. I get it. Hey, I'm an artist. Never said a good one.
Oh,
Just said an
oh.
artist. Oh,
Oh.
maybe I should get you to draw my circuits. And they'll come out right. Oh, that's great.
Oh, I can tell you the one that he showed me when we were in the private chat about doing it was much worse. It's just as funny.
Yeah, that was bad. That was you got the point of it all, but it was bad. That's all we can say. Okay.
Oh, this is the best. Oh.
Yeah, here's a good comment for you. What do we do today, Pinky?
Yeah.
That was a good cartoon as a kid, man. I love that cartoon.
Oh.
Yeah.
That's so cool. Yeah, I'll figure out a circuit. I got a couple different ones, Gerald, that I can do next week. I can do the frequency circuit and the duty cycle one.
Yep.
So that's another one I got. We can look at some just simple things if you want on some high voltage stuff. Like, guys, I always do a lot of high voltage circuits. So we can do a couple of those that are real simple if you want to learn how to do something like that. And we could do the setup of them.
Yeah.
So, yeah.
I have a modified Jewel Thief I haven't showed anybody. This one's kind of a special circuit that we can get into in the future. It's simple, but it's different. It includes an Avermenko plug. It includes hairpin circuit. It's about actually 10 components. So yeah, that's something we'll get into in the future. We'll do the one circuit live, but this other modified Jewel Thief it's the one that I don't know, I'd call it my own because I've never seen a circuit like this, but is it really my own? I mean, a circuit's a circuit, right? I came up with it. I'm sure somebody else has come up with it. Tell me why.
Yeah, maybe.
So, circuit's a circuit, but it's different than anything I've shown. thus far. And I can't use it very often because it's the one that blew the oscilloscope. It just manages to compress the power in such a way that it's kind of crazy, but good.
Do you ever take your oscilloscope and just put up a pickup wire next to it just to catch what's going on? You know what I mean? Just like you would like a Tesla coil, you just put it like 8 inches away to 12 inches away, and it's just the probe
static.
connected to a wire. That's all it is.
Never tried that.
You should try it because I pick up frequencies from the Tesla coil that way because you can't exactly hook them to anything. You know what I mean?
I do have a mini spectrum analyzer that I use, and I throw up the antenna and I pick up the frequency from my coil. Like I can actually, if I'm pulsing at 1,000 hertz, I see it on my spectrum analyzer. Like I can pick it up. So yeah, I know what you mean. I just don't do it your way. I use the little machine for it. I cheat.
Cheat?
Yeah. I cheat.
We all would if we had the right machine. I'll tell you that.
Yeah, I hear you. I totally hear you. I want to get this machine into everybody's hand. If I could, I'd be like, there it is.
Yeah.
Now you get to experiment with it. But unfortunately, life doesn't go that way.
I'll have to put my thinking cap on and get out of the high voltage realm and bring the voltage way down just to see what it does, because I would explode something very fast.
Oh yeah. Yeah, I haven't put high voltage to this thing. When well, I can't say that. I've done it a couple times, but to give you some reference, I don't have a lot of fear in a lot of things. Like I've gone through some crazy stuff where whatever doesn't bother me. But when you put high voltage to this, it makes me a little nervous.
Yeah.
You know what I mean? Because you're dealing with fields that are so outside yourself that don't make a mistake, right?
Yeah. Well, let me be honest with you, man. I sat there when Sean gave me the circuit last time for my other Tesla coil, the one that sparks up really big. I was kind of nervous because everything I put in there on that Variac fried it, right? It would literally be like, I turn it up and smoke starts filling the room because Nathan's frying something again. Okay. I need like a vent fan over my workspace. And that's what it would do. Okay. I never had any. Yeah. I never had any good luck with that Variac. Okay. Until Sean came along and showed me the right way to wire it. And I go, okay, now I'm good. Right. So here I am cranking this thing up. So I put it at 60 volts and they say, don't go over 60. Right. Well, yeah, I listened to that the first couple of times and I think I got rid of it after that. So you know me, I gotta fry it. So
give it some more. Yeah.
I threw 90 at it and see what it could do. Let me just say, thank God for a fuse, okay? Because the sparks went up and the fuse blew, and that was it. And I'm thinking, oh my God, I need to leave the room right now. I should not have done that. I should have waited for professional help, because I'm going to get professional help from the ambulance if I keep trying it.
You're going to need some. Yeah, I don't want to say the word, but yeah, I get you. You don't want that kind of professional help.
Yeah, that one might come too.
Yeah. I found the stereo circuit, right? So that was the other thing we had to go over next week, remember?
Yeah.
I wrote that down as a note.
Hey, there's Ben. Hey, Ben, we got a circuit for you, and it's really easy to build. So next week, make sure you tune in for Gerald, because he's got something for you that'll actually work with your coil probably a lot better and not let you blow everything up.
Yeah, it'll allow you to pump your stereo through the circuit and then into your coil system without triggering the automatic shutoff for your amp or blowing fuses or even your amp itself. So it's kind of a neat little circuit that, we'll go over. Yeah,
because Ben fried his amp and he got a new one. And by the way, if you don't mind, Ben, I'll show the video. Let me pull it up real quick. So give me 1 second.
Okay. The transistor that I mentioned earlier, or MOSFET, is an MJE13009. Just so in case anybody was curious. I know now because I have it written down.
Give me 1 second. I'm looking it up.
Yeah, no problem. And like I said, Ben, you ever make it out here, man? I got tons of stereos. I got one for you with your name on it already. And then you can give her. I think it's a 300-watt aside OnQ, the one that I put aside for you. I'm sure I'd have to go look. I got a few.
Hold on a minute. Not letting me pull up his thing anymore. I pulled it up earlier. But
It's being finicky.
yeah, hold on. Well, we'll get through that. Nothing's going to stop me, I guess. I don't know.
Put the hammer to it.
No, I got it. Okay, here we go.
There you go.
All right, give me 1 second. And let me get back and I'll share it.
When I was younger, that's how I fixed things. Didn't work, put the hammer to it. It's never going to work now. It's probably the wrong attitude.
You just force it to work no matter what. That's so great.
Yeah. You know that old show, and I know I'm dating myself here, Happy Days, where the Fonz would like bang it and it would work.
Oh, yeah.
And smash it into 100 pieces. It ain't working no more.
Oh, dude, that was like the cure for the remote, wasn't it?
Yeah.
You later learned all you had to do was open it up and turn the batteries a little bit. But no, we got to smack it against stuff and make it work.
Yeah. It was the magic bang on the coffee table that made it work again. Yeah, I got it.
All right.
Do it. Yeah, this is cool. I've seen this. Well, I've seen a bit of it.
Give me a second and I'll hit play. There you go. Ben got it up and working.
Nice. I need a spherical magnet. I don't have one. That's beautiful. And the pulse rate that he's putting it out at, even better. 7.83, man. That's the resonant frequency of the earth itself. Look at that. See, Ben's on it. He's on it. Good job, Ben. Good job.
Yeah, Ben, awesome.
Now, if we could just get you to stop playing with rodent. No, I'm kidding, Ben. I'm kidding. You've done awesome work, dude. You got your spinning before me. Now I'm jealous. No.
Just make sure you buy one at a time. Don't buy two.
Yeah.
With you, it'd be in trouble. We'll be over here laughing again.
Yeah, you're not wrong. Yeah.
Oh, thank you, Ben. That was awesome, brother.
Yeah, seriously, dude. You did it. That's awesome.
Yeah, we were working on the live, and it's just kind of frustrating. Probably new setup, everything. Couldn't, you know what I mean, get it going. Tried really hard, but I'm glad to see he got it up and going. Just a few tweaks to it. So that's amazing.
We were talking about that, and he was trying to get it done, and it sucked at what happened. But hey, mistakes sometimes happen for a reason, right?
Yeah, absolutely.
Yeah, and maybe that's why. Maybe his old amp was going, and he couldn't get it done because of that. And then it finally blew, and the new one gave him that kick. Who knows? I don't know. But awesome work. Either way, he's making that sucker spin.
Yeah. Hey, real quick, Ben, do not throw that amp away.
Nope.
Gerald is going to show you how to recycle part of the parts. Okay, because it's got a bunch of those little things on there for the speakers that you put. You know what I mean? It's got a bunch of those knobs, things like that.
Those are perfect. The back of an amplifier, you want to rip all those out, man, because you could use them for so many projects.
Show him the part on your circuit right there, Gerald, so he knows what you're talking about.
This part right here, you can see it sideways. It's where your speaker connectors, you just pull it back and you put it's got a little hole and you put the wire in. So I'm not sure if you can see that. And then there's this one here, came from an amplifier as well, but a higher end amplifier, and you spin it open and it's got a slot on the side and you just stick the wire in and tighten it. So whatever you have in the back of your amplifier, you definitely should pull it out and use those, because they're worth their weight in gold when you get enough of them.
Absolutely.
Yeah, absolutely.
I'll tell you what, I'm going to go buy some stuff in a yard sale this weekend. I won't tell them what I'm doing with it, but you know what I mean?
Yeah. I got 3 thrift stores, and I walk in, they know me, and they're like, nothing this week.
Oh,
Yeah, because I buy everything I can. Or I'll go, you know what? If I see something, and this may sound, I don't care how it sounds, but if I'm riding my bike and I go down an alley and I see a bunch of like old stereo equipment, I'll grab it. If it's sitting in the garbage, I don't care. That stuff is worth money in the sense where I use it for new projects. And if I was to buy that stuff, forget it. Couldn't do half the work I do. Right.
Huh.
So I recycle all the way. That's how I built my stuff. The very big coil you see, that was from recycled copper.
was it really?
Out of a TV, yeah.
That's so amazing. I never know where to pull this stuff. Like I know like a washing machine motor, stuff like that, those kind of things. I've used those.
Around the back glass of the CRT, there's like, it looks like just a cable wrapped with electrical tape.
Okay.
That's actually 22 to 26 gauge copper wire. And it's just wrapped around in a big circle to degauss the CRT set. So if you take that and then you wipe it with acetone, gets rid of all that gluish crap, and then you can put it on a reel and use it. That's what I've been doing. I learned that from Russ Grease, actually.
Does it have a coating on it, or is it just bare wire?
It's varnished wire. It's magnet wire, but it's just because that tape is wrapped around it, it's got sticky glue a little bit on it, and just a light acetone on a cloth is enough to take the glue off, but not the varnish. And then it's perfectly fine after that.
Let me show you what I did to my CRT TV last time. So, like you, I'm going to find a way to make it spark. Okay. So,
For a CRT TV, or basically a tubed TV, it's a 27-inch TV. The positive gets connected.
it was
to
a 27-inch.
flyback transformer.
Parts of it.
There you go. You see the back of it.
To the strap on the TV. It also has a connection to
There's
the
that big
motherboard.
cable you're talking about, the black one.
That's full of copper.
Yes, I do have to clean it. That's probably just all the garbage on there.
No, it was smoking for real. Every time I sparked it up.
Nice.
The spark cap
Look
on
at
this
the
gets
spark
pretty
it made,
big,
though.
but you have to start it real
And you
small.
pulled that right out of the TV
As
circuit?
you can see, we're about 1 inch away when we start.
You didn't like
Get up to
pull it out
about
and build
3
it,
and
you just use
3/4
the circuit?
inches on this thing. Pretty decent spark, pretty good on amp.
So you can see I just pull it apart. Yeah, you have to start it a little closer.
Oh, that's
Right.
gorgeous. Look at how
Right.
perfect that is.
Look at that.
That's nice.
Right out of the TV. I just hooked it up straight to the TV, man.
That's crazy. I've never done that. That's awesome. I've never done that. I always feared those bloody things because they're like a 20,000 volt capacitor, right? The
Yeah.
CRT glass itself, you got to ground that shit out right before you start pulling them apart.
Oh. Wait until you get a computer monitor. They don't spark like that. They jump spark. So you'll have something that's like 6 to 8 inches apart, and you just every once in a while go boom like a big lightning bolt and hit. Those are even cool.
I'm glad I never
things.
pulled one of those apart because I'd never known that. I probably would have got one heck of a shock.
Well, the capacitor goes from a 200 volt capacitor on that one to the monitor is like 400. So you could tell why it's jumping and doing that, but it's a bigger blast.
It'd be a bigger hurt too.
I can see it now. Everybody who's watching this, I might have one of those TVs, or my buddy does, and they're going to go out and, Old Man Bill says we're going to, you know what the best part about it was? You could turn the TV power on, and it would start the circuit for you, and then you turn the TV power off, and it turned it off for you.
Yeah, but the problem with CRTs, if you over amp that, I wonder if it would blow. You know what I mean? Like the CRT itself.
Oh, I don't know. That's pretty thick glass.
It is pretty thick. I'll tell you, dropping it from the top of the stairs to the bottom of the stairs in a basement, man, it sounds like a shotgun. I'm not recommending. This is not something you should do, okay?
Not at all.
But we were moving, and I tripped, and it went out of my hands, and it didn't even hit the stairs. It went all the way down, right face first onto the concrete, and just exploded. Man, that was loud. I'm telling you.
Oh my God, man.
Gotta be careful.
Oh, working on a 32-inch yet? Dude, let me tell you something. Those things are the greatest things because if you take some of them, you can make ion lifters out of them. And you don't have to do any more than what I did just right there. So,
Yeah.
You see how
never done that, but I know what you're talking about. You just pull the right off the flyback from the CRT tube, and you're using that one line, and you're grounding it out, right?
Yeah, so it grounds out, on the strap that goes around it, the metal strap.
Yeah. Dang. I want to try it now. I have 2 TVs sitting behind me here right now. Yeah.
How to build simple circuits. How do we do high voltage like the old man over there in his garage? I came home one time, Joe, and I had like 6 of them. I went over and saw a guy. He goes, "Oh, I got these right here. They're free." So I go, "Oh, well, I'll go pick them up," right? He goes, "Oh, well, I got a couple of computer monitors. You want those too?" "Oh, yeah, I do. I'll take those." Yeah. And then I got home. My wife came in, and she sees me pulling off the back of the TV. She goes, "Why do you have all these junk TVs?" I go, "Oh, watch this." So I start lighting up big old giant sparks in my garage, right? And I was turning on the remotes, and everyone would go off and go, doot, 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 doot.
Absolutely. All that power for sure. Yeah, that's a lot of juice, man. But yeah, jokes aside, this is a good comment. Everybody should pay attention to this. Jokes aside, it is really dangerous. Those TVs are not to be played with unless you know what you're doing. So that being said, we do have a lot of fun though.
Yeah.
Right. And that's how we learned how dangerous this stuff was by having fun and experimenting, but safely.
Oh my God. Do you want to see what happened to that? Let's see if I have it real quick. What happened when I blew up that one thing? I don't know if I have. Oh, I do right here. I was showing you the file for it earlier, right? That I said you can wind a coil with it.
Yeah. I remember that.
So watch this. Man, I got so many things open on my browser. So you saw what it looked like, right? Looks all nice right here, not too messed up.
Yeah.
Then I put high voltage in it.
Oh, that's all the pretty colors. Look at that. And it's spinning. It looks like the high voltage is spinning.
It is. I got my drill behind it running in a circle.
Nice.
That's so
Look
cool.
at that. I see blue. I see yellow, white. That's crazy. Is that the one that melted?
Oh, yeah, that was melted down. Well, it tells you about the color we were talking about earlier with light and how different colors come out of light.
Yep.
In high voltage, it shows you every single one of them as you do this. So
how high was your voltage? Do you remember?
I want to say it was at least 30,000. So there was maybe a milliamp in there in that 30,000. So yeah, it was a DC flyback. Oh man,
all right.
I might have another one of those. I'll hit it with an AC flyback and my voltage multiplier. It might fry quicker.
Well, your voltage multiplier, can you use that on DC and AC or just AC? Because I'm not exactly up on
Doesn't work on DC. So
doesn't, eh?
Here's the thing. If it's an airborne voltage already, no voltage multiplier will work. Okay, so if you can get a spark gap out of it already, that's at least say a half inch long or so, or quarter inch, then you're done. It doesn't go into a voltage multiplier. If you can keep it under that, you can get it. Okay. So when you use the AC flyback, it's only got like 3/8 of an inch. Okay. And that's it. Or like 5 millimeters for everybody else. and then they're good. So it doesn't allow it to spark over, because every time you build one of those, they're generally maybe an inch apart, maybe 3/4 of an inch.
Yeah,
So
maybe.
when you ramp up the voltage on those things, they start to spark over a little bit. So you have to put them in mineral oil or encase them in epoxy. You know what I mean?
Yeah.
Stuff like that.
Yeah, I know what you mean. Interesting. I played with a few flybacks, but I was never really good at it, other than, like I said, the geometrics that I work with, right? Because those are essentially flybacks, but they're DC flybacks.
Yeah, DC flybacks. They're a lot different. And it has to do with the way the diodes are set up in them. They're not really diodes. They're just wrapped plastic with a piece of like Mylar on it. It's kind of what it is. And so it only goes one way. I can't conduct back the other way.
That makes sense.
They already rectify it, or whatever they want to call it. It basically comes out as high voltage no matter what you do.
Yeah.
No getting around that. So the AC one, though, those are fun. I bought a bulletproof one, man, and it's been awesome. So, yeah, it came from overseas, cost me $30, $20 in shipping. And let me tell you what, best $50 I ever spent.
No kidding, eh?
Oh, this thing all day long, man, I start frying everything around it, and it's just sitting there going like, you got something else?
Yeah, give me
I'm
more.
like, seriously? Yeah. I got more. If I can get the ZVS to handle it, I got more.
Nice.
What I should do is take my Tesla coil ZVS. Oh, I got just an awful thought in my head, or maybe it's great. We'll take the Tesla coil ZVS, we'll hook it up to my Variac, and then I'll run it, and I'll put the thing in mineral oil. You know what I mean?
You would need to put it in mineral oil. I can just imagine what's going to happen. I hope you're wearing a stainless steel mesh suit, man.
I think I need to buy some plexiglass and put it up in front of me, make sure I'm safe.
Yeah.
You know what I mean? That thing, that's going to be bad. I know something bad's going to happen.
Yeah, that's not it's an idea for a test, but you got to be careful, man. Oh, that's great.
Oh my God, man. I have so much fun doing this stuff.
Mm-hmm.
I should just put a reel together of all the things I blew up. If constantly exploding everything.
You should. You know what? I know I have a bunch of video with stuff blowing up because I don't put it out. I should, but they're not failures. Those are learning videos for me, right? So
most of it was like fumbling with the camera while the thing was still on. You know what I mean? And I'm trying to get the video shot of it, and then something starts smoking, and I start smelling something, and I'm still fumbling with the camera, and I go, oh, there it is. And then the whole thing is done. It's fried at that point. I learned I got to start with the tripod and set it up and have the camera rolling before I start the experiment, because that way I could catch what I screwed up.
Yeah.
Where the smoke came from.
I do that just purposefully to find out where I screwed up. I'll set the camera on and be like, okay, so what am I going to do today? Oh, yeah, I got this. Okay. I'll start it, and it's like I'll do something wrong, and I'm just swearing like a sailor all through the middle of it. And that's one of the reasons why I don't put out those videos, because it's like, you know what I mean? What do you do, right?
Every few seconds is a bleep.
Not that bad, but it gets there sometimes, right? I'm dropping stuff, and one thing falls off the counter, and then the wires pull everything down, and it's just like I'm looking at it going, wow, that was dumb. And video's catching it all, right?
Yeah.
So maybe I should throw out some stuff like that.
Some of my best ones is I have a wrench, right? And I go to adjust the height on my plates on my gravity flyer, and I leave the high voltage on, and I don't realize it. And then all of a sudden I have full hand cranking on this, thing, right? Nothing's happening. And then I bump the other one to the other thing and get a full jolt of the whole thing. It's like, oh, okay.
Yeah, that's a quick ouch.
Yeah, we need to go outside and rethink our life. That's what we need to do.
When I get shocks like that, I go sit with somebody, because I don't know if something's going to go wrong, or they need to get on the phone, or you know what I mean? So, yeah. gotta be careful.
It gets so bad. The wife looks at me and go, "You get shocked again?" Yeah, yes, I did.
Yeah, it's normal.
Yeah.
Sean wants,
He's got that I need to rethink my life face on again.
yeah. Did I do this wrong? Meanwhile, your hands are shaking and you're like sweating from all that energy getting zapped into your body.
Yeah.
Sean wants a demo. A demo of which, Sean? All I see is demo. Demo.
Yeah, you want something.
He does. You want a demo of electrocution? No, I shouldn't say it.
Yeah, we'll show that.
We don't want to show that. No.
So funny, man. Your best coil.
My best coil. Ooh.
Oh.
I have to set up for that because it's it's 1.5 feet in diameter and it does some funky stuff. So I'll tell you what. I'll put out my big coil next week with the stereo sound circuit that we're going to show Ben, and we'll demo that. And we'll all see what's going to happen. Because the last time, maybe I shouldn't say that. We'll never know. Okay, we'll give it a shot. We'll see what happens. The coil I'm talking about, it's 1.5 feet in diameter, and it has 3 coils in one. There's separate taps in it. It's not just like 2 coils. It's wrapped, and then I pulled wires out, cut them, kept wrapping. So it's like 3 coils in one, and it's I could show it to you. It's hollow in the center. I might have showed it to you prior. I don't know if you remember. It's on a
Well,
board.
if you got it, show it.
All right. Grab it.
Oh man, this is so cool. Because even when they go wrong, I still love it. Oh man.
The next one I'm building is bigger.
Oh my god. I thought
I got a fat head, okay? And it's still bigger than my fat head. But yeah, this coil is it's a nice coil. It's hollow. I don't know if the camera will pick it up. But it's hollow all throughout it. I don't know if you can see that.
oh, that's cool.
Yeah. So this one has 3 coils in it, as you can see, right? These are 3 different taps. It looks crazy because there's 6 lines here. But this coil's insane. We'll test the rate. We'll test the sound circuit with this coil and see what it does. We'll put magnets in the center. We'll put ferrite cores in the center to see if we can pick some stuff up from it. And yeah, we'll do a test. Can't plug it in right now. I'd love to, but my workbench is not set up for it. Neither is my experiment camera. So unfortunately, we're going to have to do it next week. But we will do it next week. It's on my list right here.
Yeah, Ian wants to know your wrapping sequence. I think he's going to build the same one.
For that one, I have to look in my book for that one because that one's a unique wine. Okay, but I'll look in my notes for that one, and I can give that one up. Like I can show the wrap for that one because that one's
right
different.
on.
Yeah, that one's different than the coil you see me experimenting with.
Yeah.
Is it difficult? It's not for the beginner, but it's for someone who's built a few coils. So I'm pretty sure Ian can do it. Pretty sure.
Well, we've seen Ian's coil, so we know he's got it.
Yeah. So I know he can do this. It might take me to show him a form, like to build the form so he sees it. It's not a tutorial whatsoever. It's on a flat board, the form itself. Okay. So yeah, we'll I don't know if we'll get into the build of it next week. I probably could. Can't see why not after doing testing. Depends how long we go. But yeah, definitely. We'll get into that coil. I'm gonna write that down right now.
That's amazing.
Yeah, I've built a lot of different coils, man. I've tested stuff that didn't work, like in a row, and going, you know what, I'm going to give up on this. And then I got one that went through the roof, and I was like, okay, there's something here. It's got to be just right, but there's something here. So, yeah.
Oh man.
Sorry, guys. I write notes, right? Because I have so much going on. If I don't write notes, I'll forget. And I don't have a phone. Just so everybody's aware, I don't carry one. I don't use them. I used to have a flip phone. I had the first original cell phone that weighed 20 pounds. But once it went, the brick. Yeah, I had the brick. I had the brick fall on my shoulder off of a roof.
Oh
man, those things were brutal. But they worked, right? But when phones went smart, I was done. I have a computer. I don't need one in my pocket.
Yep.
You know what I mean? That's just
it's a leash. I got a leash from the wife. That's what she gave me.
Well, that's how.
She tried to present it in a pretty package. It wasn't.
And they can't get away. I see guys walking down the street and they're like, "Hey, dude, watch out!" Yeah, you know what I mean. Teach your own, but not my cup of tea. Right? It's all good though. I don't fault anyone for it. I know lots of people that have phones.
Sean loves the demos, man. He goes crazy in the comments. He wants to see that thing demo for sure. So next week, Sean, you're gonna have to wait a little bit.
Sorry,
we'll definitely get it.
Yeah, and I will find the wind configuration and I'll put the numbers out. I may have to show a little bit on how to wind that one. Maybe not. I don't know. Maybe there's a test for you, Sean. Okay? I'll give you the numbers. We'll see where you go with it.
Yeah. I'll tell you what. I'll put it right in that Fusion 360 and I'll just wind it right there and show me exactly how it's done on each step. Then I'll wind it.
I wonder if that'll work. That should work.
Yeah. Well, it'll work to show you a diagram to set it up. You know what I mean? So if you wanted to show each layer diagram, it would definitely work to show that.
Yeah, I know what you mean by that. Yeah, this one I think is fairly easy to wind, if I remember correctly, because it's so big, eh?
Yeah.
Yeah.
Now you're gonna have to get. I'm gonna have to compete with you a little bit. I'm gonna have to build something. I guarantee the first one's blowing up. I will not have success. Okay.
Yeah.
Not at all. This isn't a contest. Okay. It's going to be a massacre, and I'm going to lose. But I'll have to build something.
Hey, my first one was just like, you would have looked at it and said, dude, you're in the wrong business. Just stop. Just don't even bother. Just give away your copper. It was so bad. I'll show it. It looks like a smashed brain. It's weird. Yeah.
Yeah, so that circuit that he's talking about here, Ian, by the way, I'm going to put out a new one. The problem is the ZVS. I need to go to a single transistor, a single MOSFET in order to do it right. So because I was having trouble with it, it would do it just fine on a very, very tiny ZVS. But when I got to the bigger ones, the higher wattage ones, it didn't want to do it. So I went back to the transistor in order to do it the right way. That way it's done. And I'll bring that in next week as well.
Yeah. Yeah. That sounds good, actually. I got a little bit distracted because I was reading the comments there.
Yeah.
Jeremiah asked about the color chart winding instruction idea. It was something that I brought out on a live. I've built forms that are colored so that when you wind it, you'll do your primary and the secondary is a different color number. And when you follow that, it just makes it easier to build the coil system itself. So yeah, good point, Jeremiah. I'll bring that up next week when I show the windings on that. Yeah. And Ian, we'll get the numbers to you before next week. How fast can you wind?
I don't know. He keeps coming up with new ones all the time.
I know.
So that's pretty fast. You're
I'm
all
just
over
playing
that thing, man.
I'm just playing. I'll get you the numbers, man, and you go for it, dude. That'd be awesome. And Sean, you should do it too, man. Your coil systems are amazing, but why not try something new? I want to try yours.
Yeah.
Yeah, yeah.
Well, I'll get you Sean's information. That way you guys can communicate on it, and also do it with Ian so that you have it.
Yeah,
So
for
that
sure.
you guys can communicate. Because I'm sure some of the stuff has to stay behind the little closed door just for
Little
now.
bit.
So that's something you'll just talk off air about, and then share what you can on air.
Yeah, if that's a good idea, actually, because some things you have to stay behind closed doors for the time being, but not for long.
Yeah.
Well, let's get it into people's hands and get them working on it, right? So,
Well, you know what? They won't know how to do it until you start something. You know what I mean?
not wrong.
So
Not wrong. Yeah.
got to get some kind of understanding of a wind, and then move from there.
Well, I'll show this one. I can show the wind on this one, and it's not like the smaller one that you guys see me experimenting with. That one has a couple of tricks, a couple of secrets that have to be taught on a live one-on-one, like a class, right?
Yeah.
But this one I can do on video and show. Hopefully I should be set up for that next week. I'll be set up for that next week. It's just winding a coil is a lot different than demonstrating it and demonstrating circuits. Because winding a coil takes time. Like you're talking 45 minutes for maybe half of it, if I'm still that quick.
Wow.
But we'll see, right?
One of those all-day adventures, huh?
My the coil you see me demonstrating a lot with the 12 separate pickup coils, that one took like 8 hours.
Wow.
Yeah, because I had to take breaks because your hands cramp, because you got to hold stress on the wire when you're winding it. It's not just like you have to literally pull it from one pole to the next, to the next, to the next.
Can
So
you
it has
see you had 20 gauge on there?
Yep.
23 or something. Those are thick wires.
Yep. I've done it with 16. I got to show you my 16 gauge coil. It's thick. It's like a brick, man.
Yeah.
Yeah. Where is it? It's in the box. I may have it packed away. Give me a sec. I'll have a look.
Okay.
Okay.
Yeah, take a look. Oh man, it's so awesome. Oh, I love this show, man. Got all kinds of stuff going on. Huh. Yeah. Oh man.
That's something I was testing for somebody who stated that these coils did things they didn't do.
Okay, give me 1 second. Let me put you on the picture. Go for it.
This is just something I was playing with.
Okay.
Somebody had stated these things did certain things, so I took one look at his coil and I wrapped my own. And I tested it, and it didn't turn out quite the way it was advertised. It was just like, okay, so, but my 16 gauge, this is one of them. The small one's not in this box, unfortunately, but this is my bifilar bipolar 16 gauge. I don't know if you can see that. It's just thin. I believe
That's
this
nice.
is 2 wraps. I believe this sucker is.
That's more my style right there. Beginner.
Yeah, I could show you how
I
to
can learn that one.
Yeah, I'll show you how to do this one, Nate. You could do this one on your own. Yeah, this is my attempt at making a small heater. What I did is I wrapped it, and then I used galvanized wire on the inside. Can you see that?
Yeah, I can see it. That's so cool.
Yeah, it's a nice piece of art. That's it. It doesn't work, but it's a nice piece of art. And then this one's the crown. That's what I call it because, so it's a trifilar.
Okay.
Yeah. So as you see, it's all thin, regular, all the way around, except right there.
Oh, that's so cool.
So it's like as if you had a crown on your
Yeah.
head thing, right? So we called it the crown, and there's the back side of it. See that?
Yeah, that's really cool.
Yeah. So yeah, and this one's layered as well. I don't know if you can catch that on camera or not.
Oh yeah, I'm seeing it.
Yeah, I have another box of coils around here. I might have put them away. I may have to pull that out next week. I'll show you my other 16 gauge that's like a brick, but I wasn't in this box. Sorry, guys.
Nice.
And the other stuff's in the storage room, so you don't want me digging around. Take me 10 minutes just to find it.
No, that's good, man. That's so amazing, though. You got some beautiful coils there, man.
Yeah, they weren't. Some of them weren't easy. Some of them were simple. Like I said, some of them didn't work. That's why I wanted to show that one, because it didn't work. And it took me like 3 hours to build it. And I was like, oh, I was all excited, plugged it in, nothing. I'm like, roll it.
Yeah. Done that.
Yeah.
Definitely done that.
Yeah. Oh, well, that's how you learn.
Oh my God. My first AC flyback that I built, I got all excited. I 3D printed the whole thing, right? And I didn't even bother to look at the temperature for the wire. Okay. 165 degrees Celsius, I think. I should have bought the 220. And here I go. I wrap this thing and it's all beautiful looking. Made a nice spark like this right here, right?
Yeah.
I'm thinking, oh, this is amazing. Started smoking a few minutes later. I go, oh. So I tear this thing back apart, look at it, and it was the wires themselves that actually got too hot and they melted over. It wasn't the plastic that was doing it. It was the wires because the coating on them themselves got hot.
You put some juice into that.
Yeah.
I love this comment. I don't want to read it, but I love the comment.
That's so funny. Oh,
yeah,
man.
You know what? These coils, they're awesome. They all do different things. Every configuration has its own purpose. I stated that before. Some of them work for excess energy. Some of them work for other things that I cannot mention.
Yes.
And then some are designed for testing for anti-gravity. So I have many different, that's just my point. And I think everybody should build them. Every single coil I've got. And I've got all the numbers for every one of them. I've kept all my notes, right? So if, but you said you don't want the numbers. You just want to see the first one and then you're going to go for it. Is that what you said?
You know what it is? I guess it's just the way my mind works. I'll pull it right out of my head what those numbers are.
Yeah.
I just need to see the different patterns and then it's done. I'll figure it out. And half the beauty is I get a lot of them wrong. And then I'll find out what not to do. And then when I do it right, I'll be even happier.
That, you know what? I love that. When you find out, like when you make a mistake, there's no such thing as fail. Okay. Fail means forward, always in learning. So when I fail, I'm happy because I learned something. Even if it's just one little thing, like not to do it that way. You know what I mean? It's still learning. And that's important when you're doing this stuff.
Exactly.
We're outside the box here. There's no, there's no manual for working this. There's no, you're not going to someone to teach it to you. You have to bust your hump in order to understand how all this energy flows and how these coils work. Right?
Absolutely.
Many different, like the Tesla coil, that's the first of it all. That's like the baby of all coils because that's what Tesla was using to understand the flow of energy itself. Then he took it on to other things. He even played with geometry, but you don't see any of those systems. He talks about it in his book. He says how he got into geometrical coils. Maybe not, he doesn't word it that way, but he talks about geometry and how it's important in the flow of energy. So I kind of wonder if that later research that he was doing disappeared with all those notes.
You know what I'll try, Gerald? I got it. I'll try just one of those little star ones, right? And what I'm going to do is I'm just going to wire it to my Tesla coil. I'm going to put it right down the throat.
Yeah.
And I'm going to find out what it does. And I'm going to get me a single ball magnet, not double like you, and I'll use it to see what it does. If I can get something out of it, it pops out or whatever it does, we'll see. You know what I mean?
Where do I order a round magnet? Can I get that off Amazon?
I think so. Hey, Ben, you know where you got that?
I need to buy a spherical magnet. I've never had one. I can make my cylinder magnets hop up and spin and pop the poles and flip the poles. And then I could also make it spin longitudinally. But a round one, I think I think it would just hum like bends. Right?
Yeah.
Yeah. So, yeah, I need to buy one. I really do.
Yep.
Yeah. You need to get one too.
No,
I wonder what one would do in the center of a Tesla coil, right?
Oh.
So when you drop the wire down, I don't know how you would do it, but drop that sphere down in the center and watch her spin. I bet you.
Well, I could just build a 3D part that goes up the other side of it, so it has a stable landing spot.
Yeah,
and just have it like 4 inches from the top, and drop it in there and see what it does.
I had a spider on my hat.
Oh,
Go figure. Spider-Man. Right.
yeah. Ben says Amazon.
Okay, perfect. I'll look it up. Or you can send the link. That's appreciated too. Definitely.
Yeah, I think that'd be amazing. Just get all kinds of different things.
Yeah, well, the more tests we can do, the better, right? We can prove whether it does work or not, or it does work.
Yeah.
Jeremiah says it doesn't spin.
Yeah, he says it doesn't. Sorry, it keeps moving on me.
So we'll have to try it now, right?
Yeah.
Let's prove him right or prove him wrong.
Hey, right, wrong, indifferent. Let's just try it.
It's exactly. It's not a I'm gonna prove you wrong. It's a let's just do the experiment and show everybody it doesn't work.
Maybe the other side just needs to go to the ground outside.
Oh yeah, like you were saying when you flip it, right?
Yeah. So
maybe after that.
Yeah, maybe I ground it and I put it down the throat of the Tesla coil at the same time, and let's see what happens. You know what I mean? We could just start a fire, but that's okay. I got a fire extinguisher.
Yeah, I got a couple.
We'll be okay. Let's just see what happens. You know what I mean?
Yeah.
There's gonna be something that happens.
Take that as a lesson, ladies and gentlemen. Always have a fire extinguisher.
Yeah.
I have two. Go figure.
If you come into my garage, make sure you learn where the exits are.
Yeah.
And make sure you learn where fire extinguishers are, where the emergency shutoff is, and the call help button. You need all of it.
Yeah, that's it, man. Totally.
Huh.
That's the PPE.
Yeah.
Yeah.
Oh my God, dude. I need to get some electrician gloves or something that not so bulky so I can put them on my fat fingers. And
yeah,
then
those are hard, man, because the electrician gloves, the ones that for like line gloves, they're super thick. And if you get the ones that are over 10,000 volts, it's like a gel. So you stick it when you first get them, you stick your hand in the glove and it forms to your hand. You pull your hand out, then it solidifies, and that's your glove. Because it can't have any air gaps. It can't, because you're dealing with thousands of volts, right?
Yeah.
Yeah, I had a pair once when I was young. Once, I never worked on a line, but I had a pair.
Yeah.
I knew somebody, right? So come I know about them. But those are awesome gloves. They're just really hard to work with small, intricate things because
Sean says he's got a set, so we'll have to. And I've seen his. This is real small to his hand, so maybe they don't have a lot of bulky areas in them.
Yeah, maybe there's a new tech out of gloves for high voltage I'm not aware of. That would be awesome.
Well, he should know he's trying for 1,000,000 volts on his Tesla coil, so you know what I mean? We'll find out.
I do. I totally do. I like this is an awesome comment. This is why I think we should do a show like that. Failed experiments probably aren't listed anywhere. Because nobody wants people to know they failed. Shit. I'm going to say this right now. I fail all the time. I love to fail. It's what helps me learn. So, yeah, if we can, we'll do a show about it.
The show wouldn't exist if we didn't fail a little bit. You know what I mean?
Right? It has to. There we go. You find a little spider.
Yeah, Nathan started it. Yeah,
What? Yeah.
rocking out the music. You can't hear me say help, so I always
Yeah.
have to turn it off.
You got it cranked, and people are walking by, and the inside's on fire. You're yelling, but nobody can. They just hear the music. Yeah, I get that.
Yeah, what's sad is I take out my hearing aids. You know what I mean? When I rock the music,
Yeah.
and it's even worse for everybody else around me because it's like 10 times what it's supposed to be because they, you know what I mean?
Yeah, they hear it. You feel it. There's a
Yeah.
difference. Yeah, and you have to have it up to feel it.
Matter of fact, I got to go get one of my hearing aids this week, man, because I blew it out. I pushed the button on my gravity flyer and the ultrasound, boom, it blew it right out. Yeah. That's
That
an experience.
sucks. That's the piezo, though, right?
That is.
Yeah.
I told you it's an amplifier, so when a sound came into it, it amplified it and popped it.
Yeah.
So that's a trip.
That must have hurt. Did it hurt when it happened? No way. It just popped it.
Yeah, it just popped it. Oh, I couldn't hear it anyway.
Yeah.
Maybe I could feel it if it burned or something, but it didn't.
Is that permanent?
Yeah.
Your ear? Yeah.
Both of them. Yeah.
Yeah.
Well, too many years of being around saws and stuff. You know what I mean? Grew up building cabinets and stuff, and I owned my own shop for a while. It's just one of those things that I never wore this, and I should have, and I would have been just fine, but nope, I didn't listen, and I paid for it.
In our day, we weren't taught that it was necessary.
Nah.
You know what I mean? Like, even firing off guns, like, maybe I shouldn't say that.
Yeah, I shouldn't say that.
Yeah, sorry. I'm talking about the range, but we'll get off that topic. But even, where you would think you need ear protection, back in our day, you never did. It wasn't necessary. Right? Yeah. Now you need ear protection for everything. You can work in construction and want you having ear protection. Right? You hear that jackhammer all day long.
Oh.
Yeah. Oh man. Hours of that. Ding, 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 ding. Oh. Yeah, I've been there. Go ahead.
I used to work for a company laying the fiber optic cable.
Oh.
And we had to jackhammer out all the concrete, and then you got the asphalt you had to cut out, and then you put on the digging part to the jackhammer and you dug down. Absolutely.
Yeah. I'm trying to get this one freaking comment, but it keeps moving on me. There we go.
Oh, yeah.
Yeah.
I grew up in the day where they just put down the ghetto blasters. Like they went to the Walkman instead of the ghetto blaster. Yeah.
I should show you my ghetto, but it's not in the house right now. I got one of those big boom boxes where the speakers come out the two sides. I got fronts and it's got tweets. You can hook a guitar into it or a mic, and it's got a little scratch pad on it with a drum kit. It's crazy. And holding it must be 80 pounds, man. You can't hold it on your shoulder. You can, but it hurts. Yeah, ghettos. Remember those days?
Yeah. 1970s on the bus, man.
Yeah.
Back when I was a baby.
Or back in the 80s where they were breakdancing, so you had the bigger the stereo.
Oh,
yeah. Yeah. That's actually an Olympic sport now. Did you hear that?
Is it really?
I was blown away. It was an Olympic sport, and the last Olympics was kind of not making fun of, but bringing up the fact that Switzerland, I think it was Switzerland, some countries, breakdancing was really low level, we'll say.
Oh.
But the fact that breakdancing is an Olympic sport blows my mind, man. We used to do that on stage for fun, you know?
Didn't they make flag twirling an Olympic sport?
I don't know.
They got a bunch of them.
Yeah, they do. They have a lot of crazy Olympic sports that really shouldn't be sports, in my opinion. But that's one man's opinion. Okay?
Oh my god. That's so funny.
Yeah, hopefully I didn't get you into too much trouble doing this live, me and my dumbass comments. But,
We're all good, man.
go ahead.
They shouldn't trip out on that.
Okay, good. I try and keep my mouth in order, but sometimes it just gets away on me. Like the voices I do, sometimes it just gets away on me.
We'll have to keep you off the whiteboard on lives.
Yeah. No drawing for this guy. I was just drawing the circuit. Yeah.
That's so
Yeah.
funny.
Oh,
I love that, man.
damn.
Absolutely love it. Yeah, but when you get your printer, let me know so I can help you out and get you going because that's going to be big.
You know what? I think I might order that tonight when we get off live here. Just cause, right? Unless I get, I'll look. I want to try and find a bit of a deal, but the CR10 was the one you were talking about.
Yeah,
Yeah.
absolutely. Get that one.
So I'll
You know
see
what? And don't even look for the newer version of it. Just get the older one. Okay. Just make sure it says 300 by 300. And those are the best because they're easy to work on, real simple circuitry. And you know what? We get it up and going quick. And I got all kinds of stuff here if you need it. You know what I mean? To show you everything to get it up and going, man. It'd be way cool.
I don't want to leave that up too
Oh,
long.
God, don't do that. Yeah. Yeah, watch when you put that stuff up.
I put it up and ready. No, that's got to come down.
But that's exactly what he was drawing on the other day. Yeah, all of them together. That's what it looked like. It was
No,
a circuit.
but it was the circuit. It wasn't like I was drawing that. It just looked like.
Oh, it definitely came out like that.
Oh man, gotta have fun with life. It's too short.
Oh,
100
too
years
much
ain't enough.
fun.
I'm telling you, 100 years ain't enough. If it was up to me, we'd all live 1,000. Of course, it's not up to me, so we'll probably only live 75. But hey,
yeah.
yeah.
Oh my God. All
Yeah,
right,
so-
man.
I think
Go
we're
ahead.
gonna call it a day. Is that what you're thinking? Or
Yeah, I think we're about done. We have it figured out for next week.
Yep.
You know what I mean?
I got my notes. I'm gonna stick to them.
I got some circuits. You got some circuits. And then, you know, if anybody else comes up with some circuits and you want to get on, just like I said, go on my page, find my email, shoot me a message. And then, you know, just as long as it's real simple, just like I showed, Gerald will show that next time. And we're all good to go. And I you know, we'll have a little fun and a little learning.
Yeah, we'll have fun with learning.
There you go. Probably more fun and a good amount of learning.
Yeah, I can go with that.
Because if it wasn't fun, then we wouldn't watch it. That's just the way it works.
And hopefully nobody's gonna touch sparks, if you know what I mean.
Yeah, don't be doing that. Don't,
Yeah, that's bad.
That's my job.
Yeah, right. I'm gonna send you something just to fry.
Oh, dude.
Yep, that would be awesome.
I'm telling you right now, I'll just build a coil, just to put it on my Tesla coil and find out. And I'm telling you, I think that earth ground, I just want to see what it does. Because I think there's something there. You know what I mean? And I'm not talking the wall ground. I will literally go out and pound a stake into the ground and connect it to it in order to do it.
That will be something to see.
Yeah.
Yeah. All right, man. It's been an awesome live. Thank you to everybody that's out there. You guys are great. We wouldn't be here if it weren't for you. So, you know, we'll keep up the work. You keep up watching and give us your inputs. Let's get somebody else in here doing circuits as well. Because the more of us that get this done, the better it's going to be for all of us. So,
I absolutely agree.
Yep.
Thank you, guys. Have a great night. I know we just did. Thank you.
Awesome. Thanks, Nathan. We'll talk to you soon.